PaLM 2 is Google's next generation large language model. The model is really different than anything that we've built before. PaLM 2 is very good at math, at code, at advanced reasoning, and then also at multilingual tasks like translation. The way that it was able to accomplish this was because it was trained on scientific and mathematical data. PaLM 2 was trained on around 100 spoken word languages and over 20 programming languages. PaLM 2 is already being used to power Bard, Google's Workspace products, the PaLM API. You might already be using PaLM v2 and not even know it. PaLM 2 can translate not only spoken word languages, but also programming languages. So if you wanted to go from Python to R, or C++ to Rust, or JavaScript to TypeScript, PaLM 2 can get you most of the way there. So I could use PaLM 2 to collaborate with a colleague in a code base that might have all of its documentation implemented in Korean. PaLM 2 is also good at generating and understanding nuanced language, like idioms and riddles. And this is important because it requires understanding not just the figurative meaning of the words, but also the literal intent. Here at Google, we've been thinking about AI for years. Everything from the transformer architecture to our tensor processing units, or TPUs, our open source frameworks like TensorFlow or JAX, or many of the open source libraries that we've created. Many of the advancements that we've pioneered are in the products that you use every day. To build PaLM 2, we used compute optimal scaling, which basically means that as you're increasing the size of the dataset, you increase the size of your compute proportionally. That means that even though PaLM 2 is smaller than previous large language models, it performs better overall. Not only that, it's also more efficient to serve, and therefore more environmentally friendly. At Google, we are committed to releasing only safe and ethical tools to the public. We trained PaLM 2 to de-escalate aggressive and toxic prompting. It not only avoids these conversations or attempts to avoid them, it also steers them in more positive directions. We're also using PaLM 2 to advance research directions internally, and everything from healthcare to cybersecurity. So these models are already capable of doing so many things, but they're going to be able to do even more. And as we move into the world of multimodal models, we're going to see even more compelling capabilities. So not only being able to handle modalities like text and code, but also being able to understand and even to generate video, audio, and images. Be sure to check out the next video in this series about MedPaLM. It was trained and fine-tuned on PaLM 2 and is specifically focused on medical use cases.
Live from San Francisco. You know, we say that.
And we are live from
San Francisco.
Hi, everyone. Welcome to the Google I/O Extended wrap-up event for North America. We've had a very interesting season over the last 2-3 months, from I/O at Shoreline to I/O in Miami, and a series of I/O Extended all over North America. And I think you've seen a short video on a slideshow. My name is Anidu Dobong, and I currently co-lead the Developer Communities Program in North America. And I'm here with...
Hi, I'm Anna Nerezova. I'm very happy to be here with the gentleman next to me to wrap up an exciting I/O season. We are tuning in live from Google Cloud Next, so very historic day where you can hear truly latest developments for your business, for you in AI.
You're based in New York and you are a mentor?
Yes, I lead the GDG NYC. I'm very proud to be Women Tech Makers Ambassador, and I'm the mentor together with Jim.
Yeah, hi, I'm Jim Hudson, and I'm a GDG organizer from Modesto, California, Northern California, and also a mentor for the Pacific region for other GDG chapters here in California.
Yes. So, without much further ado, we are thrilled to begin our event today with a keynote from our esteemed Peter Norvig. He is a driving force at the intersection of AI-driven search, software development, and online education. Let's dive right in. Over to you, Peter.
Thank you. Great to be here. I'm live from Mountain View, Google headquarters. And you heard a little bit from Paige about where we are today with code in the Palm 2 model. And I want to step away from that a little bit and imagine where we might be in the future. And to do that, let's start with where we are today. With traditional programming, you instruct a computer through a programming language. But programming has evolved today from where it was a few decades ago. It used to be primarily a mathematical science. And now so much of programming is more of an empirical, almost a natural science. It's probabilistic. It's dealing with uncertainties in the world. It's observational. And we train it through examples of showing it the kinds of things it should do rather than saying step by step, here's how you should do it. So that's a change in how we do things, and we need tools to keep up with that. I want to just show you the type of progress we have. So here's, you probably recognize this is the next KCD cartoon. This is from 2014, and it's sort of emphasizing the lack of communication that sometimes happens between a programmer and a manager. So here the manager is saying, we want an app where you take a photo and check whether you're in a national park. And the programmer says, sure, that's simple. I can do that in a few hours. And then check whether the photo is a bird. And in 2014, the programmer says, oh, well, that's a research team. It'll take me 5 years. But in 2021, this guy says, well, I can do it in 60 seconds by calling out to these generative AI models. He may have exaggerated a little bit. Looks like the video is actually 1 minute and 8 seconds. So close to a minute, but maybe a little bit more. So we've come a long way. There's so many things we can do now, but we need a way to be able to call and put all these pieces together. So I think in the future, programming is we're going to think of it more as a collaboration rather than an instruction. It's not the programmer telling the computer what to do. It's the two of them working together to explore the space of the problem. We want the computer to automate more of the task, but we don't want to give up that control. In fact, we want the human to have more control over the task. So the computer's doing more and the human's doing more. We want the communication to be more natural. Yes, some of it may be in a programming language or other formal languages. Some of it may be in natural English. Some of it may be in diagrams and so on. And we want that to flow back and forth. We want there to be more feedback from the program on what's happening from the users. We want to be able to explore choices faster and respond to change. And we want more evidence of correctness. So right now, we have test suites and so on. We want to do a better job of that to eliminate bugs. Now, a lot of the emphasis we've seen so far has been on code. How do we write new code with these large language models? But as developers, you know, that's a small part of the task. And in this breakdown, it was about 1/3 was writing code. And the rest of it, we don't have as much support for. So we need to concentrate on that as well. Just writing code is not enough. And the types of problems we're dealing with are different. You know, it used to be the typical problem was you write software for a bank and there's 1,000 different regulations and you got to get them all right. But in the end, there is an exact answer down to the penny of did I balance everything properly? Now we're dealing with problems often called wicked problems, where there is no clear problem definition, there is no clear solution, there's many factors and multiple stakeholders that come into play, and you have to please all of them. So just defining the problem can be hard, let alone trying to solve it. And that's the kind of thing we want to provide support for. Now, over the last year, several people here, Andrei Karpathy was one of them, saying, well, the hot new programming language is English. And there's definitely something to that, but English by itself is not enough. But let me give you an example. So this was several years ago. I got an alert on my phone, says, depart now for return rental car to Logan Airport. So I thought, well, this is great. It's a very nice integration. This is not AI. This is before AI. So this was just traditional programming, but somebody had to parse my email from the rental car company and coordinate that with the calendar and the maps and the alerts on my phone. And that was all done just right. But then they had to spoil it all by saying time of travel, 23 minutes by bicycle. Now, in some sense, that was a good suggestion, because I commute to work by bicycle most days, and it's about 23 minutes. So that makes sense. But it didn't really understand what it meant to return a rental car. And so whose fault is that? Well, if I look at how the program was specified, nobody's job was to parse and understand what the event was. It was just to put the right events, the right maps up at the right time. So everybody did their job right, but it still failed. It's because the world is open, and we thought that this was about calendars and maps and events, but it's really about anything that could happen anywhere in the world. And so no traditional programming approach could handle all those possibilities, but maybe this AI-based approach can. And that's how the world has changed. I started to ask these large language models if they could do this. And a couple of months ago, all the models failed. You said, I have to return a rental car to the airport. Should I go by bicycle? And they all said these kind of hedge things. Well, it depends on many factors, the distance, the weather, and so on, because they're trained not to give bad advice. But this last month, finally, I get barred to say, no, you should not go by bicycle. So these models are continuously getting better. So how can we combine the best of these large language models to handle these open world wicked problems with traditional programming languages where we have some idea of correctness? Now, the eminent computer scientist Edgar Dijkstra said, in the discrete world of computing, there's no meaningful metric in which small changes and small effects go hand in hand, and there never will be. And if he's right, then gradient descent that we use to train these models is doomed, because how do we make a large language model better? Well, we notice an error, we make a small tweak to one of the parameters, and hopefully that decreases the total error, and we keep on making those small changes. But Dijkstra's saying that won't happen. And he's got a point, right? So you take a program, you change one bit in the program, and it could do something completely different. So maybe that means that a neural net will never write code. On the other hand, Arthur C. Clarke said, when a distinguished elderly scientist states something is possible, he's almost certainly right. But when he says it's impossible, he's very probably wrong. So maybe Dijkstra wasn't quite right. And Ken Thompson, one of the developers of Unix, said, when in doubt, use brute force. And our TPUs say, yeah, I got this. So even though it is really difficult to explore this space of programs and one bit can make a big difference, it's still possible and it still works most of the time. Chris Peach teaches the introductory computer science class at Stanford, and he says large language models solve 100% of the exercises. And we've seen multiple types of approaches to this. I want to look in depth at DeepMind's AlphaCode. And here's a sample that they solved. So the problem is described just in terms of informal English, and there's a couple examples of input and output, and now you have to write a program to do that. I won't make you read all this, but I'll say very quickly how this problem works. So the idea is you're given two source strings, a source and a target, and it's asking you, can you produce the target string by typing the input source, except that for some of the characters, you can replace it with a backspace. And that backspace means that you don't see that character and you don't see the previous character if there is one. So if you got ABABA as an input, you could type 3 backspaces followed by the B and an A, and that would give you the target. So you should say yes. There's other possible places to put in the backspaces that would give you the same result, and the answer should be yes regardless. Now here's the program that AlphaCode comes up with, and it gets the right answer. So that's pretty impressive, and it's not that long a program and not too hard to follow. But I decided, well, I'm going to do a code review. So the first thing is, if a novice programmer had written this, the first comment would be, well, you have to document this. Put in doc strings and comments for your functions. And maybe it's better to make this be a function and not straight line code because it's easier to test functions. And little things like just the spacing goes against the PEP8 Python standard. And the variable t is used for 2 different things. That's not great. And these 1-letter variables maybe should be more descriptive. And these 10 lines are a little bit verbose. And here's a strange thing. So they set up this variable c, which looks like it's going to be used as a stack. As you pop things off of B, you store them on stack C. But then stack C is never used anywhere else in the program. And so I think what's happening here is it's been trained on past programs. It identified that this problem has something to do with stacks. That was great. And it says, well, often when I'm popping things off one stack, I save them someplace else. So let's do that just in case. And then it never went back and recognized that it didn't need that stack C after all. And then it's an inefficiency here in doing the popping, a little bit of verboseness. And when I look at this, I see this Lake Wobegon effect of half the programmers are below average, so half the output code is below average. And there has been some attempts to say, can we train these models on only on more high quality stuff? But it looks like we're kind of right in the middle, and we want to do better than that. So the question is, how can we get there? So here's an imaginary collaboration with some future automated programming tools, some add-ons to POM2 and to AlphaCode to make it better. So say it produced that first result. I want to be able to say to it, so I know this problem came from a programming competition, and often people in programming competitions go as fast as they possibly can. And don't bother encapsulating it as a program, but I want you to do that. And I want you to put in the doc string. So it can do that for you. And then I can say, well, your code's a little bit confusing and it's not obvious that it's correct. Can you show me another version that is obviously correct, even if it's inefficient? And so here's one which says, well, I'm going to generate all possible outputs that could result from either typing a backspace or not for every possible character. And then I'm just going to see if the target is one of that set of possible outputs. So that's more obviously correct, but inefficient in that it looks at all possibilities. And then I can say, let's have some tests. These are the 3 tests that were given in the example from the problem. And I can ask the system, generate some more tests, and maybe it can be clever in the way that it comes up with the good tests for this particular problem. And then I can say, now try these two approaches. And yes, the obviously correct one takes 10 times longer, but they both pass all the tests. So that gives me some confidence that the efficient one implements the same function as the more obviously correct one. And then I can go through and say, well, is it better to scan right to left or left to right? And part of the key to understanding how this works is saying, if you scan left to right, you never know, should I output a character or should I backspace over it? But if you scan right to left, it's always the case that I can't output a character if it's not the one that's expected, because there's no further possibility to backspace over it. So you want the system to recognize that. write a function based on that. We'll skip over all the details. I wanted to show here the system giving a very long and detailed explanation, or sort of a proof of why it's correct. But the details really aren't that important. What is important is that you can have a conversation with it. And here it says you can have a recursive version that tries all possibilities, or you can show that you can take a greedy approach and that will always work. And then you said, well, if the greedy approach always works, then it doesn't have to be recursive, and I won't have to worry about overflowing the stack. So I can write this non-recursive version. And then I can go back and say, you know, that first version used lists rather than strings. Was that a good idea? And the answer is yes, because Python strings are immutable and lists can be popped. And it can finally come up with this version, which is sort of a third the size of the original and is more clear and precise. And so we hope we could arrive at something like that. So that's the imagined conversation. And the question is, can we get there? Can we get it to be right by training it better? And what processes would lead it to be able to have that kind of conversation? And I'm encouraged. And here's a collaboration that was posted by this guy, Daniel Tate. He said, I asked this system to create a game for me, and it was able to do it. So he said, can you invent a logic puzzle similar to Sudoku that doesn't currently exist? And it came up with an example. He didn't like that. So he said, invent another one. And it came up with this one. And then he said, that seems like a fun game. Can you make a playable version using HTML and JavaScript? And it could do that. And then it said, can you make it a little bit prettier with some CSS? And it did that. And here's the game. So there's this array of numbers, and on the rows and columns, there are totals that you're trying to hit. And the idea is you delete some of the numbers so that all the totals add up in each row and each column. And that was what the program produced. And then he went back and forth a little bit to say, let's make it a little bit prettier. He didn't think this was beautiful enough. And this idea of circling the ones that you're going to keep and Xing out the ones that you want to get rid of, that seemed like a nicer approach. So in the end, he got a program. He could have written it himself. He could have come up with the idea himself, but the system did maybe half the work, and he did half of the work. And that was a great collaboration. So how can we make this type of collaboration better? And so remembering that writing code is not enough, we want to look at the whole software life cycle and say, can we speed up that whole cycle? You start with a strategy, a design, and mostly what we've been looking at so far has been focusing so tightly on this development part of writing the code. But that's just one part. You have to go on to testing and deployment and maintenance. And all these parts are important. And the development is maybe a third, maybe less. So, so here's a picture of that life cycle. And notice that at every step, you've got teams of people involved, and you've got documentation that's produced. And there's only one of the steps where you're producing some code or maybe a neural net. And the cool thing about the neural net is you can backpropagate. If there's an error, you can go back through the parameters and adjust them to eliminate that error. But you can only do that through the neural net. You can't do that everywhere else. And so I'd like to see a system where you can backpropagate through everything. If the designers came up with a strategy for the user interface, and now the world changes somehow. Suppose people are using devices with different size screens. So the assumptions that were in that original document are off. I want the system to be able to notice that error and backpropagate through everything. I don't want these design documents to be dead that are stored on a shelf somewhere. I want them to be live and to be interrogated by the system and to be updated when necessary. And I think if we have that, everything will be a lot more flexible, more responsive to the user. So one great example of this approach is by Danny Tarlow and his team at Google, a system called Didact. And the key here was that it was trained on the process of software development rather than just on the final code that solves the answer. And so if you look at the process, there's a developer, they write some code, they run some tests, they submit it for review, comments come back from the reviewer, changes are made by the developer. So the DIDAC system is trained in a sort of reinforcement learning manner on this whole workflow, not just the final code, but where did the code start? What are the comments that led to it being changed along the way? And that allows you to fit in better to this type of workflow and to avoid some of the mistakes that were made along the way. Another approach I think is really important is probabilistic programming. It's never quite taken off. The idea behind probabilistic programming is you describe a model of what might happen, and it's probabilistic because there is uncertainty in the world. And it's relational rather than just saying, here's how to translate inputs to outputs. It's saying, here's the measurements I have, and here's what I know about the relationships between things. And maybe I only know the output and I don't know the input, but I should still be able to describe that and then have the system use kind of Monte Carlo approaches to be able to write code that can optimize based on this probabilistic model. And so I think that will be important for a lot of these wicked type problems that don't have a deterministic specification. The idea of hierarchical decomposition is very important. And we've seen that where as a problem gets larger, as there are more tokens, the large language models tend to break down. And the traditional approach to that is hierarchical decomposition. Let's say, let's decompose the problem into sub pieces, solve those pieces individually, and then solve the problem of combining them. And this work with Parcell, done largely at Stanford, takes that approach. And I think that's going to be crucial to making success and being able to scale up where we can go. And here's just some examples of how that system works, how it can take multiple different languages, a robotic planning language, a theorem proving language, and it's fluent in the Python language and so on. And it is able to take each one of those, understand and translate between English and the formal language and go back and forth and then combine them together. And I think this idea of code is a very powerful language. So English is an amazing language, and all these other natural languages are amazing. And the large language models learn so much just from our history of what we've written down. But code also has a special point. And we've seen models like Palm 2 take advantage of that to say, because there's been this consistent problem that the large language models just aren't very good at arithmetic. They can do 1 and 2 digit numbers, but when you get into the 3 or 4 or 5 digits, they tend to make mistakes. And recognizing that, Bard will, when given a problem, will write a piece of code to solve it. And here it's done that in one sense, it's done that exactly right. It's taken this problem. If I sell 378 apples for 39 cents each and 224 oranges for 43 cents each, how much do I make? It wrote a program, calculate earnings, that does that exactly right. Unfortunately, it didn't quite get the connection between the code that it wrote and the way it describes it exactly right. And it ends up saying you'll make 243 and 74 cents when it should have said 243 and $74, right? So that conversion between cents and dollars, it messed that up in the process of going into and out of the code. So we need to just do a little bit better on using the codes as a check, but making sure we understand how that transition goes from the general model to the specific code model. And I think we're almost there. And I just want to say, sort of as a last point, that this idea of compression encourages generalization. And so what do I mean by that? Well, so there's a lot of stuff happening out in the world. And most of what gets into a large language model comes from what is written down in books and on the web and so on. And so somebody decided this was important enough to write about, and that's what gets put into the model. So that's one part of compression. And whether it's written language or photos or video, somebody had to decide this is worth putting into the model. And then we have a further point of compression where we say our models are going to have a certain number of parameters, whether it's a certain million or billion. If there were too many parameters, then the model would just memorize the input exactly and would not be able to generalize. If there are too few parameters, then it can't hold all the information it has, and useful information starts to drop out. So you've got to get that just right to get the right level of generalization. And then there's this further step of going from a question to an answer through an intermediate representation that generates code or some formal language. And I think that's a really useful step, and we've seen some examples of that. And it's useful because, yes, the intermediate language could just be English or some natural language, but then we have no way of verifying that it's right. You take a paragraph of English, you can kind of ask, does that make sense? But you can't run it and execute it and get an output, and you can't verify it for syntax errors or runtime errors. But with a piece of code, you can. And so forcing your answers to go through code gives you this extra level of testability and reliability. And so I think we'll see more and more of that. And maybe, here I show Python and NumPy as the intermediate language. It doesn't have to be that. We can be developing other formal languages that have the property that they're checkable and executable, and have our large language models move through them. And I think that's a great area of research. It's figuring out what those languages are. So why don't I stop there and open it up for discussion? Okay. Is there a good way to use prompt for LLM to better dealing with different program lib API versions? Oh, that's a great question. Yeah, and I think that's an issue right now because training these models is so complex that it isn't always done on a regular basis, and so often you end up with it's been trained on older versions of libraries, and it's not up to date. I guess the best thing you can do is just make sure you specify version numbers in your description, and say I want such and such an API version 3.4, and make sure you pay attention to the version number. And so bringing that to the model's attention is a good way to do that. But the models aren't built to consistently worry about that in the way that, say, a Kubernetes container is. So I don't have a great answer right now. Got an answer from Bard for Hugging Face, but Bard just gave me some code for old Hugging Face version. Yeah, right. So that's going to be a problem until the models are updated to the latest versions. And we've seen some places where some of the systems are now trying to do that, are trying to put in a fine tuning to keep things more up to date. So hopefully in the near future that will work out better. Question: I want an LLM that specifically knows about recent Flutter, not old Flutter. How hard is it to get it to prioritize modern state of the world? So I think that's the same question. Can the relative age of training data inform the LLM for bias? Yeah, that's really important, and that's always been true, right? So I've been involved with Google Search for 2 decades now, and we've always had this trade-off of how much should we trust old versus new. You have more data on the old, more signals on whether people trust it or not. And then there's the new, and maybe the new is better and up to date, but maybe the new just comes from spammers, and we should stick with the old and reliable. So that's been a problem for search optimization, and it continues to be a problem for these large language models. So it wouldn't be enough just to say, let's attach a date to everything and trust the more recent stuff more. You want to look at the more recent, but you also want to worry about is this spam, and you want to not lose the high quality stuff just because it's old. Well, you do a new course like your Udacity Design of Computer Programs, CS 212, but showing how you would use LLM's Copilot. Yeah, that's really interesting. I had a lot of fun doing CS 212 at this Udacity class. I'd like to do something like that again. And I think you're exactly right that, I sort of used bare bones Python in that class because I didn't want to have it focus on specific technologies. I wanted it to get outside of the core of what programming is. But, as I'm saying now, maybe what programming is has really changed, and maybe there should be a class like that. So, I've got a few notebooks up on my PyTudes site on GitHub, and there's a couple of them that start getting into large language models. I was playing with one over the weekend, a little game that Sergey Bolonji, a professor, came up with, and so the game was think of two words where one word you get by just dropping a single letter from the other word, and then write a crossword puzzle clue for that, and see if people can guess what the two words are. And so you can easily say, well, what pairs of words are in the dictionary that are where one drops one letter from the other? But then, you get things like cats and cat, where this cat drops the S from cats. And that's not really interesting because they're too closely related. So I said, I want to come up with interesting pairs that are not closely related. What's the easiest way to do that? Oh, I'll just download some word embeddings and then create all pairs and sort by the largest distance of the word embedding. So then you get two words that are one letter off, but are very different from each other. And that seemed to work. So that was just a super simple example. And I think it's interesting to go back. And so you make a great suggestion. I should take some of the examples from 212 or take some new examples and say, how would you address them today? That's quite different from how they were addressed a decade ago. So thanks for that suggestion. Please expand on the Monte Carlo methods for programming. Okay, so here's this idea of you observe something in the world, and when we write a regular program, we say we're going to give you the input, and the program's going to compute the output. Sometimes you say, well, the input's hidden. We don't know what that is. So, the input is the state of a patient's health, and then the output is their blood pressure and their results on these medical tests. And you want to say, what's the input given the output? So that's not like regular programming where you go in the forward direction. Is where you're kind of making inference in the backwards direction. And one way to do that is the Monte Carlo approach. Is named after the casino in Monte Carlo, where you have gambling games where you roll the dice or spin the roulette wheel. And so you say, let's take a random possible start state and then run it according to the rules of the game and say, does that produce the output that I observed? If so, then that's a possible start state. And then you just do this thousands or millions of times. And now you get a probability distribution over here's the likely possible starting states that could end up in the correct output state. So it's kind of rolling the dice because you don't know where you are, and then computing where you likely arrived at based on that. Is it reinforcement learning training getting over supervised learning approaches for training LLMs? Yeah, so that's really interesting. So I think the big breakthrough for LLMs is that we were able to mostly train them with self-supervised learning. So what does that mean? It means we gave them a bunch of text, and normally in supervised learning, you have a person come through and say, here's a problem and here's the answer. That's too hard and expensive to hire people to do all of that. So instead, we said, we're going to self-supervise. We're going to make up problems by saying, here's a sentence. We're going to blank out one word in the sentence and ask the system to guess what that word is. So it's supervised in the sense that there's an input, a sentence with the blank in it, and an output, the correct word to fill in the blank, and the system has to guess that correct output. But we didn't have to do any work because you can automatically blank out any word you want. So it's really easy to come up with these lots of supervised training examples. And that works pretty well. So it learns by just filling in the blanks of the words. It learns what these words mean, more or less. It learns the syntax of English. It learns some degree of argumentation, as Paige was describing in the video earlier. But sometimes it's not quite enough, right? Because sometimes there's lots of words that could fill in the blank, or sometimes you want to evaluate not just what's the one word here, but what's a whole possible paragraph. And they are just kind of looking at filling in the blanks doesn't tell you the right answer. So we do this reinforcement learning with human feedback, which means we ask the system a question, sort of after we've trained it up on the fill in the blank one at a time. We ask the system a question and say, come up with two answers. And then we show that to a human judge and say, which of these two answers is better? And then we adjust the system so that it produces more of the better one. And having that human in the loop is important because we don't have anything that can answer. We don't have a supervised way of saying which is better, these two. So the human has to be there. And then the reinforcement learning says, what led to this? So supervised learning says we're only looking at one step at a time. Reinforcement learning says we're looking at multiple steps. You generated a whole sentence or a whole paragraph, and now we're just saying this is better than that. And the reinforcement learning has to say, given that feedback of this one was better, which steps along the way were the crucial steps that led me to get there? And that's how we improve these answers on paragraph level questions. And that's how programs that play Go or chess learn to make better moves, only being told, did you win or lose the game in the end? And they can figure out which step along the way was the most important step.
Hey, Peter, it is great to have you here. Thank you so much. I've got a question for you.
Great.
As good engineers, we kind of know that one of our jobs isn't just to look at the rosy side of everything, but it's also to look at the risks, to look at the pitfalls, and to figure out how do we mitigate those risks and pitfalls. And I guess my question is, what are those risks when we're talking about using machine learning systems or LLMs or whatever as we're bringing it into this coding process? And then what do we do about it?
Right. So I think that's right. So I think there's some risks specifically from the technology. I think more of the risks really come from the problems rather than from the technologies or the solutions. And I think there's a lot of confusion about that. So people are saying, oh, I'm worried about these AI programs because they can make mistakes. And it wasn't the AI program's fault. It was that you're asking it to solve problems in which it's much harder and it's easier to make mistakes, right? And so any result could have a problem, right? So there was a lot of discussion over these AI systems that help judges make parole decisions. So they predict, is this defendant going to recommit a crime? If they are, if the prediction is that they are, then the judge will be less likely to let them have parole. And so a couple of things happen. One is you say, how well do these systems perform? And the answer is, well, pretty well. And in fact, they do better than judges with these kind of fancy AI systems. And even a simple system which has, a simple system that could like fit in a 280 character tweet, that also does better than a human judge, right? So the simple system could be, if the defendant has 2 prior convictions, or their age is such and such, and they have something else, then yes, else no, right? That performs better than a human judge, right? So you blame the AI system when it's not perfect, but it is doing better than the alternatives. Now, the other thing you want to worry about is not just the overall performance of the system, which gets to a pretty good level, but also the fairness of the system. And there it starts to get controversial, because you start asking, well, what do I mean by fair? Well, one thing you could mean by fair is calibration, saying, if I say you're 60% likely to recommit a crime, then that should be equally true whether you're black or white or male or female. And North Point, the company that made this system, says, well, look, we did this test, we're well calibrated. It's almost the same regardless of what group you're in. Therefore, we're fair. Stop bothering us. ProRepublica, the journalist who criticized them, said, yeah, you're right. You're well calibrated, but I don't think that's the most important point for fairness. I think the most important point for fairness is equal harm. So when you do make a mistake, either a false negative or a false positive, who does it hurt? And then they showed that it hurt black defendants twice as much as white defendants. And so they said, that's why we think you're not fair. Now, as an engineer, you might say, okay, there's 2 metrics. Let's just optimize both of them. Unfortunately, the way the math works out, that's just not possible, in that the 2 metrics are always traded off, one versus the other. And so now you're left at this point where the answer for what's right is not really a programming question or a math question. It's a societal question of, what do we as a society think is fair? And if you could tell me that, then I could go implement it. But that's what we're arguing about, is that we don't know what's fair. So I think in cases like this, what's really important is bringing all the stakeholders into play. So very early on, don't just say, oh, well, I got an algorithm that's really fast. It's order n, so I'm going to implement that. But say, what is it that we really want? And who's being hurt? And who are the stakeholders? And typically, you look at this at 3 levels, right? So you say, first, I want to build a system for the user. In a case like this, who's the user? Well, it's the judge. So you say, well, I want the judge to have a nice display with pretty charts and graphs and so on. And, the font should be really pretty and the output should be clear. Yeah, great. But don't end there. Then say, well, who else is involved? Well, the other stakeholders are the defendants and their families. And if someone recommits a crime, it's the victims and their families. And so take them into account, take their viewpoints into account. And then look at society as a whole. And what is the effect of mass incarceration or discrimination at a societal level? And so as an engineer, you thought my job was just to make a pretty screen for the judge. But really, you want to say my job is much larger than that. I have to take all these things into account. Or, similarly, if I'm building a self-driving car, yeah, I want the person in the car to have a great experience, but the other drivers and the pedestrians, I'm also responsible for. And at a societal level, it's, am I causing more traffic? Am I causing people to live farther out in the suburbs and disrupt urbanization? Are people losing their jobs? Those are all parts of the problem too. So kind of expanding your viewpoint on what's important, I think, is one of the key lessons.
Great, thank you very much.
We'll integrate LLM outputs to a knowledge graph, improve the performance of LLM for coding. Yeah, so that's a great question. I've been doing AI before it was cool. And in the 80s, we were essentially building knowledge graphs. And we didn't have this idea, there was no Wikipedia to download and so on. So it's kind of, well, we had to build everything by hand. And we were limited in how far you could go, and we felt we hit this asymptote of you get to the point where if you add one more fact, you're as likely to break as many things as you are to fix. So there are huge advantages to just using text, which is kind of freely available in mass quantities, but there are also advantages in having something that's better curated and which you have more trust in. And a knowledge graph is one way of doing that. I think it's not the only way. I think another approach is to integrate out third-party data sources or APIs, right? So, it makes sense that you should be able to ask a large language model, what's the capital of France? And it should know Paris. But I don't think it makes sense to expect a large language model to say, what's the capital of every county in every country in the world? I think it makes more sense for the large language model to answer that by saying, well, I don't know, but I know a reliable atlas where I can look that up. And so I would like to see more of that type of integration. And some of it might be a knowledge graph that we built and put together, but more of it, I think, might be just these third-party APIs to say, for this question, here's where I want to go to try to get the answer. Let's see. Do we have more questions?
Hi,
Hi.
Roida here, and I've been a huge fan of your work. I studied a lot of the courses that you taught on Udacity, and I gained a lot of knowledge. I'm really an advocate of democratizing AI, and I would like to know your advice on how to make it more accessible for other people. Thank you.
Yeah, that's great. I think we've definitely gone a long ways towards doing that, in that, it used to be you had to be an expert programmer and you had to sort of go through grad school to be able to even understand how any of the tools work. Now we've got these interfaces where you can ask these large language models anything and you're interacting with them. I think, and we also have some tools that make it easier for people to understand what's going on. So to me, education is really the key to democratization, to show people this is how the technology works, this is how it affects your life, and you can be a part of it. It's not something that these experts way out there do. This is something that you can do. And so things like the pair groups explorables, where you can play around and build a little system to do classification. So build a system that says, well, this is one signal and this is another signal, and I'm going to build a visual system that recognizes that. In 5 minutes, you can do that, and you kind of get the idea that one, it's possible for me to do that, and two, how do those systems break? Maybe I train it and it starts picking up the background rather than picking up the foreground. So now that that's a possible failure mode for these types of systems. So I think making systems that are easy to get started, that are accessible and interesting to people, and just pushing that and showing that someone like you can do this. And that's something I've tried to do throughout my career is to welcome more people in, and I'm glad I was able to, that you were able to connect with that, and other students have. And I think we need more of these types of introductory materials to get people started, because once they get started and they get excited, then they're on the right path and they can get there. But it's this introductory part to tell people this is something that could fit for you. It's not just for these other people. I think that first step is the most important one. What are near future trends regarding LLMs, in your opinion? one of the things I'm really excited about is this multimodality, and Paige mentioned that. So I said that we have this kind of compression that we write down what we think is important about the world, and then we train on that. And so far, most of our systems are built on either on text or on images. But I think when we get another order of magnitude increase in processing power, then we'll be able to do videos as well. And I think that's interesting because I think video is a less biased view of the world. When I write something down, it's what I think is important, and I wrote it down. When I take a photo, I click the shutter and point the camera in the direction that I think is important. But with video, sometimes it's just a stream that's just coming. And so it's more, here's what happened, rather than here's one moment that someone wanted to capture. And so I think we'll learn a lot more about the world when we have access to video.
Hello, this is Noble. Thanks so much for such an insightful talk. This is a general machine learning related question, but going off of that theme of fairness bias that was asked earlier, there's a tension in sort of enterprise context or sort of real world context. There's a tension between accuracy and fairness or bias, right? When practitioners try to apply these concepts in the real world. For example, when you constrain optimization for fairness or bias, you sacrifice performance or accuracy. What's your thinking behind these trade-offs, and how? What's your sort of guidance there or counsel there?
I don't think that's necessarily a trade-off, right? So I mentioned there are cases where yes, there are trade-offs. If you increase one thing, you decrease another. I think for a lot of these fairness issues, I think of the trade-off more of in development time rather than in accuracy. And there's no reason you can't improve everywhere, but you got to just make these choices of who counts. Who am I going to spend the engineering effort to try to improve the experience for? And it's definitely true in machine learning, but I think it's always been true. So anytime we make product decisions, before there was machine learning, before there were computers, we're always including somebody and excluding somebody, right? So, I sell a product, a toaster, and it comes with an instruction manual. If the instruction manual is only in English, then I've left some people out. Now, I get feedbacks from my customers, and I say, okay, I'm also going to make the instructions in Spanish. Now I'm included one more group, but there's still other groups that are left out. And every time I make that decision, so it's not really a trade-off of accuracy for fairness. It's more, is it worth the time and effort to go and get that Spanish translation? And is it worth it to then do the third and fourth and fifth language? And I think that's what enterprises have to focus on. And I think they'll see a reward from treating all their customers fairly. They'll gain new customers, and they'll gain respect from the existing customers to saying, yeah, I like that you're sticking up for fairness and that you're supporting everybody.
Thank you, Peter, for that fascinating talk. Great opening session for us, and I love that Lake Wobegon slide there. So, and thank you for all the great questions coming in from the audience, from the other speakers. So next up, we have Alan Furstenberg, a Google developer expert, GDE, who will explore the intriguing relationship between LLMs and bridging the human-computer interactions. So welcome, Alan.
Hey there. Thank you. It is great to be here. I always love talking to these groups. And it's always wonderful to reach out and be able to talk about this stuff. And it was great to see Peter. It's going to be a tough act to follow. So as you said, I'm going to be talking about using large language models to bridge the what I like to call the fuzzy human digital computer boundary. But more importantly, and I think the message that I hope everyone takes away from this, if my presentation suddenly stops, my connection crashes right now, what I hope everyone takes away from this is that the LLM tools that we have today enable every developer, no matter what your skill level of machine learning is, from a total novice to an expert, no matter what programming language you are using, you have the tools now to be able to do some amazing things that we were never able to do before. My name's Alan Furstenberg. I'm a software developer and consultant. I work for a small consulting company located in New York. But I'm also a Google developer expert and a Google Cloud Champion innovator. And basically what that means is that I don't work for Google, but I work pretty closely with Google's developer relations teams and engineers to help them understand what we as developers need to use Google tools better, faster, more efficiently, and so forth. Also, what I do is help us as developers, the entire developer community, understand what Google tools are bringing to us, how we can use them, what they are good for, and how they take us to the next level. And as part of that, I'm contributing to an open source project called LangChain.js or LangChain JavaScript. You may have heard of LangChain. It started as a Python project that helped enable Python developers get access to a wide range of these new LLMs that were coming out. The JavaScript and TypeScript version is more or less the same vein. A lot of my contributions have been, how do we get these libraries that are codifying certain patterns that we're seeing more and more in using large language models? How do we use them with the tools that Google is providing? I'm the co-host of a podcast called Two Voice Devs, originally started about 3 years ago to talk about voice in the programming arena and how programmers can use audio. And increasingly, we're doing more and more with AI and machine learning. And I run weekly office hours as well. Here's some basic info on where you can find me. Spiders.com is the company that I work for. Prisoner.com is my personal page. It's easy to find me on Twitter, Blue Sky, and on LinkedIn. So what's the fundamental problem here? Fundamentally, it kind of boils down to humans are analog creatures. We think of things in fuzzy terms. We have broad scoping ideas of when we think of things. But computers don't work that way. They're digital, they're discrete, they're concrete. Everything in a computer fundamentally boils down to a 1 or a 0. And everything is built up off of that. As you can kind of imagine, the two of them don't mix terribly well. So traditionally, what we've had to do is we've had to think digitally in order to work with computers. We've developed programming languages that boil things down into discrete digital chunks. We've built databases that store discrete and finite values. We've taught people how to ask computers questions using the discrete language that they are good at, and we've built new ones. But LLMs kind of turn that around. LLMs can understand, and I put that very carefully in quotes here because I know the significance, but LLMs understand us by taking our fuzzy notions, by taking the things that we are vaguely expressing and turning those into the discrete sets that it knows how to deal with, that turns it into values that it knows what they are and what they mean and how to work with them, that turn them into numbers that it can compute how close things are. That gives us an incredibly powerful tool that for the first time, we no longer have to teach people how to do something. We've taught a computer how to learn from us and learn what we want. But it's important here to understand what LLMs are and what they are not. Coming up in a little bit, good friend of mine, Noble Ackerson, has a quote that he's used that I absolutely love, and that's to remember that large language models are not a source of truth. They're not search engines. They're not good at being search engines. But what they are is a way to transform one thing into another. So they're good at doing things like turning phrases into code fragments, turning phrases into search terms, turning phrases into numbers. And then on the other side, doing that transformation in reverse, taking the results of a query and turning that into a textual result that can be spoken to us, or that a human would find it pleasurable to read, rather than trying to, look at a bunch of brackets that may not mean anything. When we take that and combine it with the APIs that we as developers already know and are familiar with, then our applications can do amazing things. This is a powerful new tool that all developers are able to tap into. So how do we do that? Kind of breaks down into 4 parts. We're going to first get a request from the user in some fashion. We're going to use the LLM to turn this request into a discrete representation, into those numbers. We're based on those discrete results from the LLM, we're going to transform it into other discrete results. We're again going to end up with more concrete information that the computer is familiar with. But then we're going to use the LLM to take those results, turn it into response to the user, send it back to the user, and repeat the process. So what does that look like? So here's one example. User types something into a chatbot. We're very familiar with this notion these days. The LLM will take this information plus other context that they already have. Maybe they're going to be taking into account the time of day or the day of week, or the fact that the user likes to use bicycles instead of cars. And they're going to turn it into, say, a function call and describe what those parameters are. It's not going to make the function call, but we've given it a list, for example, of known functions and what those parameters are in each function. And maybe we're going to it's going to give us back what that function call is and what the values of the parameters are. We're then going to, after some sanity checking, execute that function with those parameters. And like any good function call that we've built, it's going to be returning back into a nice standard format, an object format or a JSON format of some sort. We're then going to take that JSON notation, again, a standard notation, feed it into the LLM, but also feed into it the original request as some additional context, and give it a prompt to say, turn this into a chatbot response. We get that response, we send it back to the user may ask another question, and we keep going. What's another example? Okay, so what if the user is going to be talking to a voice assistant? The LLM will take what they've said, what their spoken text is, turn that into what's known as an embedding, or a vector of floating point numbers that kind of represents what it is that the user has just said. It'll then use those embeddings to locate in a vector database other documents that are nearby that request. And these are, as Peter kind of alluded to, these may be things that are similar to what the request is, or may address it in some way. So it gets back a bunch of documents that may answer the question. Now, given those documents and given the original request, it may send all of that to an LLM and say, summarize this, and summarize it using SSML, which we can then speak back to the user. And again, we repeat. Another example, what if the user asks a question about data that they're searching for, that they want to summarize? Maybe it's in a spreadsheet, maybe it's in a database, who knows? The LLM can take the question and the schema from our database, for example, and we've prompted it to create an SQL query. Again, after doing some sanity checking to make sure the SQL looks sane, we're going to execute that on our database using API calls that we know and we're very familiar with, get the results from the database, and again, feed those results along with the initial question back to the LLM to summarize, respond with that summary, back to the user, and repeat the question. But what tools, what skills do we need in order to do all of this? The most important thing, and again, I cannot emphasize this enough, we have our basic skills already. As developers, we understand APIs and libraries that we're familiar with. As developers in a particular domain, we may understand our business logic or the problem domain. All of that are the most important things that we need to fundamentally bring this up. We'll need to know some additional things, of course. For example, we need to know how to do LLM prompting. And that's a whole host of conversations that are out there about learning how to do prompting, how to fine tune our prompting so that we're asking the question in just the right way. But fortunately, there are tools out there that are helping us. Tools such as MakerSuite from Google, which gives us an environment where we can build in prompts and fill in parameters and fields for those prompts, or the Vertex AI Model Garden, or Generative AI Studio. All of these are tools that help us build our prompts and get familiar with how to write a prompt. And then we need an API or libraries or something that gives us access to the large language model itself and lets us streamline asking those questions, getting those responses. And here's where something like LangChain and LangChain.js can really help us out, because it helps put all of that together and lets us just get on with asking the question without having to deal with too many details about how to make those calls. If we look quickly at, kind of that middle question there, taking prompts and applying parameters to it. Prompts, and again, this is a whole subject that we really could spend hours on. But generally, what you want to do when you're building your prompt are set up things such as giving it a role description, help it kind of frame the question in terms of what kind of expertise you're asking for, give it operational context, what the schema is, for example, maybe user-specific context. They like to ride a bicycle. In a lot of cases, we can give it examples, and this really, again, helps set it up for what the structure is going to be that we are expecting the LLM to return. We want to give it task descriptions, and then most important, we want to give it other user inputs, and then finally, what's the ask? What do we want it to give back to us, given all of this other information contained in the prompt? Beyond the prompts, however, we've also got parameters. And these are things that let us kind of tweak how we expect the prompt to behave. So at the very basics, what model are we going to be using? What temperature or how much randomness do we want to introduce in the question and answer? For things that we want very solidly grounded, like code that comes back, we don't want much randomness at all. Whereas for the more flexible human-sounding answers, we want a little bit of randomness so it doesn't sound as robotic. We'll also want number of tokens that are returned, some safety filters, or particularly if we're dealing with things that are skirting the edge of medical information, we don't want it to return too much medical information because that could be dangerous and somewhat out of our control. There are also other esoteric parameters that you start getting into when you're playing with these models, things like top P and top K. Most of them have to do with randomness. In general, most people don't worry too much about them. As I said earlier, there are tools like MakerSuite, which are available from Google and available for most everybody in North America today. Most everybody in the United States anyway. Sorry, Canada. What this lets you do is manually enter prompt information, save it, and adjust the parameters. One of the other neat things about MakerSuite that I really haven't seen too many other places is you can kind of treat it as a templating system so that you can do things like say, here's where I'm going to want to fill in a value, but use the rest of it as a boilerplate, and then go in and try out some things. Most importantly, however, I want to emphasize, keep experimenting. Prompt development and design is still more an art than a science. So the more you play with it, the more you fiddle with it, the better your chances are of getting good prompts. And then there's LangChain. As I kind of alluded to, LangChain helps streamline a lot of the processes and helps introduce patterns that are well accepted and understood in the LLM community these days. So at the very basic of it, it gives us tools like building prompts, taking templates to fill in values that may come from the user, applying it to a wide range of models. So for example, you may want to try something on text, chat, or an embedding model that's currently available, or you may want to try it on the next version of something that's available and try things out and see how they work. Or as you're moving towards an enterprise system, you may want to move from the MakerSuite set of tools into something working on Google Cloud like Vertex AI, both of them using the PaLM API or the PaLM model under the hood. It also likes working with things that it calls documents. And this allows for atomic component of data. So basically taking web pages, PDF documents, and so forth, and breaking them down into smaller chunks that the AI may be able to better work with. Especially when we're dealing with things like conversational AI, where there's a back and forth, we also need something that's known as memory to store those historic conversations, to store the context that the user is giving us so far. Then we start moving to more advanced things. How do we group these things together? So for example, we will want to build a prompt and collect information from the user and apply it to that prompt, and then take that prompt, feed it into a model to get a result, do some processing, and then feed it into a different model. Things like chains and agents let us stream those together, and there are some fairly standard components that have increasingly been growing, so you don't need to write much of the code at all. You're letting the library do a lot of that processing for you. Okay, I already hear you. We're 15 minutes or so into this. I haven't seen a line of code yet. Show me the code. So let's go back and look at the example. This would be the third example that we talked about before, where the user is going to ask a question about data to search for or summarize. We're going to have our LLM take the question and the database schema information and create an SQL query about it. We're then going to evaluate that query using standard tools that we already know, get the results from the database, and then once we have those results from the database, send both the original prompt and those results to an LLM to summarize and respond. So what is that going to look like? And what I've set up here is a database that has two tables. It's kind of mimicking the notion of a user bulletin board system. So we've got a table of users and when they last logged in, and we've got a table that consists of everyone's posts and who posted it and when they posted it. So the first thing we're going to see about our code is that it almost completely mirrors at the highest level what our data, or what our flowchart earlier just looked like. We're going to get the request, we're going to turn that request into SQL, we're going to run that SQL, and then based on both the original request and the values that we got back from the SQL, we're going to get a response, we're going to show the response, and we're going to keep doing that. So let's see what each of those four functions look like. Now, the first of which is really, and I'm using JavaScript for my example, but again, I want to emphasize, you can do this in any language. All these are illustrating, and what that flowchart illustrates is whatever language you have, you'll have the same kind of pattern. So to get the request, we're going to use the readline library that's part of Node.js. Prompt for the request, get the value, return the value. Simple, straightforward, uninteresting. But it's building on the knowledge that we already have. Let's get some more interesting stuff. Okay, so how do we turn that request into SQL? And although there's a bit of setup here, fundamentally, what we're doing is just 2 lines. So in the setup, we're going to build a query model. And in this case, I'm going to be using the Google Palm model, which is available through MakerSuite. And I'm going to set the temperature on that fairly low, because what I want to do is I want to turn what the user has said into an SQL command, and I don't want it making stuff up. We're also going to need to set up some things like the prompt string, and we'll look at the prompt string on the next screen, and build that into what they call a template. What the template does, and this is a LangChain notion, is that it's going to take a value or take a set of values, in this case it's going to be the request, and put that into this boilerplate that we've built. Then finally, we're going to utilize something called an LLM chain. And what the chain is basically, what this LLM chain is, a very simple, straightforward chain that says basically, given the template boilerplate and certain values, apply that to create a prompt, send the prompt to the LLM, get a response. So we've set all of that up so that all we need to do when we call the function with the request is that we call the chain with that request value and we get a result. And that's it. All of the hard work has been done for us. We're basically just configuring a bunch of stuff. Now, the big notion in here, what we needed to configure is, what does that prompt look like? And in this case, it's a fairly extensive set of prompts. But you'll notice most of that is just that we're defining what the two tables look like. We're defining what our users look like, a full name, when they last logged in, and we're defining what their posts are. An identifier for the post, the user, what category it might be in. Maybe we've got some rating, we've got a date for that. So this is all some information about the post itself. And then we're telling it basically, we're kind of giving the instructions then to the LLM, kind of leading it on. It's a database expert. It knows what databases are. Okay, here's what a schema looks like. The user is going to request something, and you should give an SQL query text, and you should just give the SQL query. We don't want explanation, but here's what it's going to need to do. Always use fully qualified names of tables, bunches of other stuff here. Here's where the request is going to be put in, and we're prompting for the query. Here is our ask. That's going to be what goes into the prompt to hopefully turn that into SQL. So now from this, we have some SQL. What do we do with it? Well, for those of us that know SQL, what do we normally do with it? We need to send it as a query somewhere. One of the things I point out, though, and I have this in a fix me here to remind us, is that we should sanity check what the SQL is. We don't want it doing things like deleting database, inserting stuff into the database. So there are some basic checks that we can do to make sure that this is just going to be a select and that it doesn't have any odd characters that are trying to escape our sandbox. But then you have to remember, these are things that we've known how to do for a while. SQL injection's pretty well understood and SQL cleaning's pretty well understood. So hopefully we can apply those skills that we have to this. And then we make a database call, which we know how to do. And we get the results back and we return those results. Okay, so now we've got a bunch of results. What do we do with it? And again, this code looks very, very similar to the earlier one where we're sending the request off to the LLM. Again, we're going to be using the Google PaLM model from MakerSuite. But you notice in this case, we've changed the temperature. In this case, we want a more friendly response rather than a robotic sounding response. So we're going to give it a little more leeway and randomness. We're again going to use a different prompt string. And one thing to note, and again, we're building a chain, we're building up the template from it. But one thing to note when we make the call, that we need to pass it two pieces of information. We're going to be passing it the request, what the person initially asked for, and we're going to be passing a JSON representation of the values itself. But otherwise, this looks very, very similar to the previous code that we had. Our prompt here, however, is much, much simpler. We're basically saying, you're a data analyst. You've been given the question that was listed below, and after doing the research, here are the results that you found. Now, what I want you to do is provide a solution as if it was being read out over the phone. And that kind of prompt, as if it was being read out over the phone, is kind of more to urge it into a way that sounds user-friendly. It's not providing too much information. It's not providing it in weird date formats. It's meant to sound like a human is going to be listening to it. And then we're going to fill in that boilerplate with two pieces of information: the question that the user initially asked and the data that we just got from our database query, and then give it that lead. Give me the answer now. Okay, so what does this look like? So here's an actual run from the code. I'm actually using code that has a couple more comments in it that tell us what's going on at each step. So when the user asks, how many users do we have? We see that it turns it into an SQL prompt, basically selecting how many rows there are in users. If we had something about, how if a user was active or inactive, it might add the flag to check that as well. The result it gives back is pretty straightforward. It's not a complex set of rows here. Basically, the number 5, we pass that question, that answer to our second LLM, and it gives us, according to our records, we have 5 users. Human sounding, easy to understand and digest. What about us asking when John Doe last logged in? Well, it knows that John Doe seems to sound like a full name, so it's going to be setting up a query against the full name, and it's going to be getting the last login field from this. The result that it gets back is, again, a fairly straightforward data structure, although it indicates it's a BigQuery timestamp that has a value in it. But all that it returns to, that has a full date and time, but all that it returns to us is the date. So again, we can see from this how it has taken a very human question, turned a very human and very fuzzy question in some ways. You'll note that some of the fields, some of the questions, for example, when I say, when did it last log in, doesn't always in every case match the fields that I'm looking for. It's taken our fuzzy question, turned it into a discrete thing, an SQL query, executed that SQL query, turned that into a discrete answer, and then turned that discrete answer back into a human fuzzy set of text. So I have a little bit of time, although not too much, to take some questions. If you want to learn more, here are a few URLs for you to take a look at. For more about POM 2 in general, there's a link. To learn more about the Makerspace set of tools and API, makerspace.google.com, and to learn more about LangChain.js, there's the GitHub repository. I look forward to seeing what you can do, because again, I want to emphasize, I cannot emphasize this enough, you can do this. These tools are at your command. Thank you very much. It's been great to speak with all of you, and I look forward to seeing what questions you have and what you do with all of this, these features that are now at your fingertips. So the first question we got, is it possible to force the LLM output to be deterministic so that the LLM answer can be safely forwarded to downstream program APIs? The answer is yes and no. We can certainly get it to be more deterministic. And by deterministic in this case, though, we mean that it's more repeatable. So given the exact same input, we'll get the exact same output. Whether that output is exactly what we want is tougher. The first thing to do is lower the temperature as low as you reasonably can. A temperature of 0, 0.1, 0.2. I tend to like 0.2 because it tends to pull things out a little bit more accurately. But it's something you need to play around with. I think the underlying question here, though, is how do we make sure that what we've got from the LLM can be sent to the API? And the best answer here is check it. You know, what we're getting should be a fairly well-known and understood data structure. And from here, we can now use tools that we already have to do sanity checking. We should make sure that the data structure meets the data structure that we want, that it has fields that we expect, that it isn't malformatted in some way. But we've got lots of tools that are not AI tools and are therefore much, much easier and cheaper to run to do those sorts of things. Two other things to keep in mind that may help in some ways on this. One is that when you're building a prompt, give it examples. Remember, these LLMs are pattern systems. So if you give it examples of patterns that you're expecting to get back, it'll try to follow those patterns. That's kind of how it's built to do. The second is, and these are starting to get to be more advanced concepts, that we're now seeing LLMs that are checking the results of other LLMs. So you will, in an SQL query, for example, you may send it a query, and it doesn't need to know anything about the structure, but you may send it, here is a query that we're about to execute. What are the safety concerns here? Or rank this in terms of safety from 1 to 10. And for something that's a 10, you reject it. And for something that's lower, maybe you handle it in other ways. So those are, a lot of techniques, but there's also a lot of conversation, a lot of innovation that's going on with all of these sorts of things. This is a fantastic question. I don't know where to start. That's hard because you're seeing a lot going on out there with LLMs these days. Everyone is talking about it. I would start by looking at Google's Maker Suite, which is just a playground where you can start building prompts and experimenting with it and seeing where they come, where they go. This also is a great opportunity for me to give a plug for your local Google developer group. And part of the reason is because there you're going to find a community where lots and lots of other people have the exact same question that you have. Where do I start? I hear a lot about LLMs. What do I do? What are they? How do I use them? Again, they're also going to talk about how do you build one, how do you train one, how do you do fancy things with them. But fundamentally, these are the communities that can be out there and helping you understand, how do you get started? What's that first step? Where do you, I saw this code, where do I go with it? I'd also, if you're familiar with Python or you're familiar with JavaScript, turn to the LangChain communities, because the LangChain communities are doing some incredible work out there to help people understand how to use these LLMs in your code. Again, bring your base knowledge and then up it with what these LLMs can do. Anna, hi. You're muted, Anna.
Thank you, Alan. It's great to see you. Alan is a very frequent speaker at GDG NYC. And great to see you wearing your signature Google Glass. Hope you update that soon.
I would love to update it soon myself, as long as it comes in blue.
Yes, follow Alan. He is a fantastic Google developer expert who holds office hours almost daily, I feel like.
No. It's every week on Wednesdays. Tune into me on Twitter to find out the exact times.
Yes, perfect. You learned a lot on LLMs. And of course, GDG NYC, we have monthly events on AI. And now I'm very happy to introduce Roya Kandalan, who is a senior machine learning researcher and an amazing woman take maker ambassador who wants to make AI accessible to all. And she just led 2 machine learning professional machine learning engineer courses for New York and Boston. So I love working with her. Roya, you have the floor.
Thank you very much for the introduction. Thank you for having me. I really appreciate it. And we just listened to 2 very amazing talks by Peter and Alan. I personally learned a lot from them in my professional work. And I'm going to change the gear a little bit here to see how we can use AI for a different purpose. So here we are going to use AI for assistive navigation technologies to help people with visual impairment. So before we dive into the technicality of this work, let me introduce you to myself. My name is Roya, and it means a very sweet dream in Farsi. I was born and raised in Tehran, and then I moved to Dallas to continue with my grad studies under the supervision of Professor Kamishna Muduri. He is a well-known scientist in the field of unmanned airborne vehicle. After graduation, I moved to Boston, and currently I'm working as a senior research scientist at Aware, and we are working toward basically building a biometric solution that are free of bias and are impartial. I'm also a proud member of Women Techmaker Ambassadors, and that's a program provided by Google to bring more women to STEM and to break the barriers that has been built historically for women to work, especially in STEM areas, because we are trying to hold each other's hands and lift each other and grow with each other because we are stronger together. I'm also a co-organizer with GDG Cloud Boston. As Miss Anna mentioned, we are trying to provide more education to the community to bring AI and different technologies to everybody around us to make it really accessible for everybody. So without further ado, let's start with how it all began. As I mentioned, I'm from Iran and my advisor is from India. I want you to imagine yourself if you were in an area that you have, it is unknown to you, and your eyes are closed. I want to really try to get the fear that you might feel. The fear that you are feeling is exactly reasonable because vision is the most precise channel to gather information and reason in location. People who have visual impairment try to use other senses to collect the information that they require to have to basically understand where they are in their location. And assistive technologies can help them to essentially gain this information. But most of these assistive technologies and essentially the city structure that can help people with visual impairment navigate independently belongs to more developed country. When the person is in a basically more developing countries, some of these assistive technologies can be really expensive to get, and sometimes they are not even available. Based on my background, I think I was more exposed to these sort of challenges. So with the help of my advisor, we were trying to build a technology that is not just a theoretical easy way for a smartphone, which is top of the line, but something really affordable that people who are maybe having some financial difficulty can also afford. So to build this technology, we require to answer few fundamental questions. So remember that we are trying to locate a person in an area. We want to know what is the best path for them to reach to their destination, and we need to make a decision about a map. In addition to that, given the difficulties and challenges of visual impairment, we require to know information about the occlusion and dangers in the area. On top of that, all of this information must be some way conveyed to the user. The initial design sketch that we came up with was, as you can see in this slide. The main core block of the system is a wayfinding module. It is responsible for finding the user initial location, interacting with the map, and also navigating the user to their destination. Given the user has visual difficulties, we want to gain some information about the dangers in their area and be able to pass all of this information compactly to the user. Okay. Breaking it down takes this problem into 3 different stages. The first stage would be the pathfinding. As I mentioned, for pathfinding, we need to know where the user is initially because they have no clue about their basically their initial location. Also, we want to be able to find the best path for this user to reach to their destination and to find the best set of actions to follow to reach to the destination. In addition to that, we need the second modulus obstacle avoidance to first detect the obstacle in the area and second, provide information about the relative location of this obstacle toward the user. Lastly, we want to first give the user a choice whether what extent of information they want to hear from us. And we want to be able to communicate the instruction about the actions that they must take to the user. And lastly, we want to be able to receive input from the user. So let's see, in this presentation, I'm trying to walk you through all of these stages and see how we can tackle each problem. But before we get into each of those problems, given that we had this constraint of budget, we require to know what is the best platform for this work. Again, because of the initial thought that we want to be helpful to people who might not have the financial means to get the best, basically a smartphone, we wanted this platform to be an accessible and affordable gadget. We wanted it to be able to do some minimal computation, and just for localization and other matter, we required to have internet connection. Given that we want to do localization and navigation, we wanted some inertial measurement unit or IMUs to be able to reason in location. At the time, we came to decide to use Samsung S7. This project started in 2016-2017. At that time, this phone only cost $120, which relatively was a small amount of money for a smartphone. It was able to handle Android Marshmallow with octa-core CPUs and a tiny GPU. It also basically supported VLAN and Bluetooth and had accelerometer and gyroscope. So all of the requirements that we had for this platform were basically satisfied by this phone. Now that we know the problem and we know where we want to go and what platform to build it upon, we are ready to basically dive into finding the best solution. The first piece of this puzzle was to find the initial location of the user. As I mentioned, we are thinking about a user who cannot reason in location. So they have no clue about where they are in their where they are located. Traditionally, people think about GPS or trilateration to reason about location. GPS signals are essentially satellite signals helping us to figure out where we are and how to get to the destination. However, GPS signals are not available in an indoor scenario. And trilateration are heavily prone to noise because of all type of basically signal to noise ratio issues and shadowing and bouncing and all of the problem that a signal can encounter when it's tried to transfer in an indoor area. Essentially, we cannot calculate geometrically where we are just by using trilateration. But all of this noise can actually come to our help. There is this other method called fingerprinting. By fingerprinting, we are trying to build basically a barcode for every location in an indoor area. When you are walking in an indoor area and your phone is connected to the Wi-Fi, you are constantly getting signal from all of the available Wi-Fi beacons. And your phone is measuring which one has the highest basically strength and tries to use that one to connect to the Wi-Fi. But you always get all of this information. So if you were to walk into the hallways and collect information about the strength of all of the beacons that are available to you, you can build something called a radio map, which is an association between the real map of the area and how much each of these Wi-Fi beacons have a strength in those locations. So you are building this signal strength map. It requires a lot of data collection, and data collection is always the most challenging part. The first part was me to go and walk through the area of my choice, which was the Department of Electrical Engineering at the University of North Texas, and annotate the map of the building with 1 feet square. And then I needed to build an application to essentially have somebody walk through this 1 square meter location and tell me what is the beacon signal strength in each of those. That was the first time that I had to build an Android app. Thanks to Dan Golping, who is a Google Android developer advocate, and his amazing course on developing Android app, I built my first app for this data collection. The app would allow me or any user who would help me with data collection to enter the coordinate of XY coordinate of their location based on the annotation that I already made in the building. And it would collect all of the signal strength for all of the beacons that were available to me. By walking throughout these hallways 1,000 times and getting enough of information and some more data processing on this data, I was able to pass this information throughout a neural network and get the information about the XY coordinate of user location. At this point, I just checked one of the pieces of this puzzle. I could say I know where my user is when they are seeking my help. But the bulk of the problem is still there. I needed to know how I can get them from their initial location and take them to their destination, or quote unquote navigation. Traditionally, navigation is happening through pedestrian dead reckoning. It's a fancy way of saying that I know how much is my stride and which way I'm heading, and by putting one step after the other, I can tell where I'm going. However, this method is prone to error. There are two main sources of error. One is the compound error that happens because we are building the next step on top of the prior step. So if I have 1 degree of basically miscalculation in my first step and I take 100 step, instead of going to the north, I might just go to the south or something in that realm. The second problem is the measurement error. As I mentioned, on the phone, we have accelerometer and gyroscope. Accelerometer calculates acceleration for me. To get from acceleration to displacement, I have to integrate acceleration to get to the velocity and integrate over velocity to get to the displacement. It means that a tiny amount of error when it comes in acceleration can be a significant error when it comes to displacement. So it raised the need for some error mitigation method. The method that I used for that was particle filter. In 2016-2017, when I was working on this project, Google's self-driving car was the word of the mouth. And Dr. Sebastian Thurn, who was a faculty at Stanford, while he was working on this project, he had a course on basically navigation, and he would discuss different methods of removing the error with navigation, essentially. One of the interesting methods that he mentioned after the traditional method of, let's say, Kalman filter or extended Kalman filter was particle filter. The idea is that you basically have all of these particles, and based on the observation and measurement, each of them has a probability of continuing the progress. And by resampling and just choosing those that have the higher probability, you are removing those particles that can do something impossible. The simplest way of thinking about it is that it allows you to make sure that your user is not going to the second floor if you do not have enough of measurement to support that your user is passing through a staircase. Particle filter is amazing because it can handle basically non-Gaussian noise and non-linear system, which are the requirement for navigation in an indoor scenario. At this point, I was able to tell where my user is, and I was able to follow them along the path that they are taking using the sensors that were on the phone, and also using the error mitigation method to follow them along. I still needed to find the best path for them to reach to the destination. Right now, when you are driving and you use Google Maps has this cost associated with you turning left being more costly than you turning right. So if it can find a path that allows you to turn right instead of a left, it tries to do that. To do that, there is an algorithm called A-star. A-star allows you to find the best path not only by putting it to be the shortest path, but to associate the cost with every decision that you are making. So here, because I was dealing with a visual impaired individual, it was important to me that I don't want them, for example, to pass a staircase. That's essentially a costly action. So A-star method would allow me to guide my user in the best possible and less costly path to get to their destination. With that being said, I had a technology to allow me figure out where my user is, what set of action they need to take to reach to their destination. So it could be applicable to any person who is, for example, in a foreign country in an airport, and they want to find their basically destination gate. So they didn't know where they are and where they want to go, but they have vision to reason about the dangers in their area. However, a part of assumption for this work was that the user is visually impaired, so they do not have information about the obstacle in their area. For obstacle avoidance, I needed to be able to find these objects, find these quote-unquote obstacles, and estimate the relative location of this obstacle toward my user, and to be able to gain this information and pass it effectively to the user. Obviously, object detection comes to picture. For object detection, I use a YOLO, a TensorFlow version of YOLO, which was available on Google API. And I cannot talk about TensorFlow and not to mention Lawrence Monroy, whose courses on TensorFlow was really amazing for me in my professional career. I met him in person at I/O, and it was an amazing event for me. He has these TensorFlow courses, and basically it allows me to get the YOLO and do transfer learning to introduce all of the new objects that are not a part of YOLO package. For doing that, I use a Google Cloud Platform that allows me to take this model and retrain it just for a few top layers to introduce new objects. And thanks to Google, the first $300 was basically free credit. Also, in 2016-2017, we were introduced to TensorFlow Lite. It's an optimizer and wrapper for the neural network models that you create, essentially making it with a smaller number of bits, allowing you to get this gigantic model and make it so tiny that you can fit it on an Android device. It allowed me to have an obstacle avoidance module as well. But everything so far doesn't convey information to the user. So I required a way to be able to convey this information. I wanted the user to be able to tell me how much information they want to gain, whether they are on a run or they want to explore the area. I wanted them to be able to tell me where they want to get. And also I want to be able to pass all of this instruction to the user. To pass this information to the user, naturally, I use Google Text-to-Speech. It would allow me to explain the options to the user and have them confirm some of the question that I had for the user. And also, it would allow me to give instruction and tell them about the obstacle that they have. The more complex part of this puzzle is how to get feedback from user. The first thing that a developer could do was to use tapping. You always can have tapping on a screen of a phone as a way of receiving feedback from the user. I use it for emergency situation, for app to start, or for the user to tell me if they want to have some information right away. But it would have been impossible to finish this project if it wasn't for Google Speech Recognition API. For people who are familiar with the field, they know that building a speech recognition API is immensely difficult because the amount of annotated data that you require to cover the diversity of tone and accent it's so much that it's not possible for somebody to build. Thanks to Google Speech Recognition API, however, I was able to gain information from my user, so essentially take the information in a meaningful way and have them to declare their destination. With that being said, I was able to build a proof of concept for this technology, and I was able to show that with putting the right algorithm by side of each other, you can actually help a person with visual impairment to navigate in an indoor scenario independently. And at this point, I got graduated. But to take this problem, to take this project and technology and to really apply it in real world, two more problems must be tackled. First is when I was explaining the work, I explained that I had friends who were helping me with data collection to build a radio map. The radio map was the association between the signal strength from different Wi-Fi beacons and the location on the map. practically, it's not possible to constantly update the radio map. And the radio map, because of the dynamic nature of the Wi-Fi beacons, are going to be basically out of sync so quickly. So to be able to really build this project in a real life, we need some way of incentivizing people to help us to collect this data and constantly updating the radio map. We can use crowdsourcing essentially to have other people helping us with this updating. The second problem was in the initial problem I mentioned that in the fundamental problem I mentioned that the usage of a map is a question. And in the explanation I mentioned that I used a priori information about the map, and I knew I do have the map, but essentially if you want to use it for a new area, you can the map is not available. So there is this method called a structure from motion that helps you to take a few pictures and turn it to a 3D map and a 2D map to be able to use it for this project. With that being said, I'm pleased to say that I'm also part of a PhD committee member right now for people who are continuing this work at University of North Texas. Once again, thank you for being here and thank you for this opportunity, and I would be happy to answer any question. Thank you. Do we have questions?
Hey, Roya, that was awesome.
Hello. Thank you.
One question for you. Do you happen to have your research paper and maybe the repo available for anybody who wants to play with or collaborate with you?
I do not have a repository for this, but my dissertation with all of the code is available, I think, on university website.
Awesome. And which chapter are you with? And do you want to tell a little bit about it? Because you've been training a lot of our community on some of these technologies on a regular basis. You want to share that?
Of course, I would love that. So I'm a part of GDG Cloud Boston, and we are trying to help. So I'm an ML scientist, obviously, and naturally, I tend to teach ML. We recently finished the certificate for Road to ML in Boston and New York, and I'm happy to announce that in late September, we are starting a Road to TensorFlow certificate based on the book by Lawrence. So, yeah. Sorry, Alan, I cannot hear you.
Sorry about that. That was a great presentation. Thank you very much. I think one of the things that I had while watching you go through this are what were some of the biggest challenges that you faced as you were going through it, or what were some of the setbacks that you encountered, and how did you work past those?
So to be honest with you, this project took me 4 years. So my whole PhD, okay,
Wow.
I know. My whole PhD was working on this problem. And for each of these algorithms where they required for me a learning curve to get to them, to get to find the right algorithm to do the work, and also to be able to build this on an Android device. As I mentioned, the Android device that I was using was computationally not really powerful. So one thing that I vividly remember was to build the particle filter and to find what is the basically optimum number of particles that I could use to make sure that my user is still safe, but my device can handle the computation. There was basically a sweet spot to not to break the code and also not to lose the precision.
Wow. Okay. Thank you very much.
Thank you very much. It was great to talk. and have this opportunity. And I cannot still believe that I stood on a stage which was filled by Alan and Peter. I'm over the moon, truthfully.
Awesome. Thank you so much, Roya. That being said, I'm going to introduce our next speaker, Victor. One second. Victor, welcome.
Hi.
What are we going to talk about today?
Hi everyone. My name is Victor Divya, and today I'm going to talk about a project titled Automatic Generation of Visualizations and Infographics using Large Language Models. Any chance you guys can see my slides?
Let me put that right now.
Great. Okay, so hi everyone. Thanks for making our time to attend this talk. Today I'm going to talk about a project that I'm kind of really excited about, and it kind of lies in the domain of using large language models. And I know Alan sort of spoke about how these models are super effective in building like really interesting like HCR interfaces. And so my talk is just a level down the stack today, looking at a specific problem, how we can use LLMs to generate visualizations, and then think through all the problems that sort of come up with trying to accomplish this task. In terms of background, I'm an ML GDE, and I joined the program about 5 years ago, and it's been such a pleasure to be part of this really, really exciting community. Lots of really interesting people, lots of really interesting technology ideas. And I recall that like 5 years ago, I started out with contributing to just training TensorFlow models and specialized data, contributing to TensorFlow.js, contributing pre-trained models to that repository. And over time, it's been just really, really interesting, sort of contributing to the TensorFlow community and also conducting ML research. In addition to that, I'm also a research scientist at MSR. So my background is human-computer interaction. And I spend a lot of time now looking at scenarios where we pair a human with an ML model to solve a task. So for today, I have 4 high-level areas I'd like to talk about. And so first of all, a motivation. Why might we be interested in using LLMs to automate the creation of visualization? I'd love to get into a demo, assuming all goes well and the demo gods are kind to us today. And then next, I'll look at the system components. What are different system components that we sort of string together to make such an application possible? And then I'll look at how we could think of ways to evaluate systems like this. It's kind of really important that we have some sort of evaluation metric or evaluation suite, such that as we make changes to the system, be it prompts, code scaffolds, error correction, we just want to make sure that all of this improves the metrics and we don't have degradations. And then finally, I'll conclude with conclusions, lessons, and next steps. So one thing I wanted to mention is that all of this work is public domain. Code for this project is available on GitHub under the MIT license. So I definitely will encourage you to sort of look through the project and sort of get started. And I'll put a link in the description at the end of the talk. Okay, so in terms of motivation, why might we be interested in automated visualizations? And so I'm sure that many of you have had this experience where you might have a spreadsheet with hundreds of thousands of data points, and then it doesn't really inspire thoughts and insights. But then if you see these charts where you see like, let's say, histogram or bar charts, you can start to make good decisions of, it looks like our sales was really high in March. Like what was driving that? How can we replicate that sort of spike in sales across the rest of the year? And so the core idea is that visualizations reduce the cognitive load associated with sort of extracting insights from large data sets. However, the challenge is that most users just don't have the skill or just don't have enough time to put in the effort to create these visualizations. And so the idea is that in order to come up with good visualizations, first you need to get familiar with the data. You need to ask the right questions. And once you've done that, you need to come up with the right encodings or transformations. Do I use a bar chart? Do I use a pie chart? do I aggregate my data? Do I create new columns from existing columns? And so there are a lot of decisions that you need to make. And then finally, when you figure out all of these, the final thing is to sort of implement the visualization. So in this case, you might use a GUI like Excel or Power BI, or you might just write code with Matplotlib. And either route requires a bit of skill, and a lot of users don't have the skill. And so from this perspective, there's been a ton of research and ways to sort of recommend visualizations to users. And the net goal of this is that for users who don't have the skill, then all of these abilities become available to them. And then for users who already have that skill, maybe we can sort of cut down the amount of time they need to create visualizations. And so the core value proposition is, how do we empower users in the creation of visualizations? How do we make visualization authoring a better experience? And so ideally, with LLMs, we can simplify this by making the core interface to all of this process text. And so imagine that the user could just point a tool or a system at the data, and then proactively the system could come up with a few interesting things. Let's say explore the data, come up with good hypotheses or questions. And for each of those questions, offer visualizations. Or we could offer a natural language interface where they could say things like, I'm interested in this. Can you help me create visualizations that like sort of address this question or this goal? Okay. And so right now I would like to switch a bit to a demo. And I'll talk a little bit about how you might want to spin up this demo in the future. Let's do a screen share. Okay, so the interface you see on the screen, and Madisha, if you can give me a thumbs up just to verify that like the screen share set is going through correctly, I think that would be great. So assuming all goes well, the screen share that you see is the interface for a tool called LiDAR. So LiDAR is like a tool that implements some ideas for generating grammar agnostic visualizations using LLMs. The idea here is grammar agnostic means that LiDAR makes a core fundamental decision of representing visualizations as code. And so as long as we can represent visualizations as code, it means that like we can use any programming language, R, Python, and we can use any visualization grammar, so Matplotlib, Seaborn, Altair, as long as those visualization grammars can be represented as code, we can then use a pipeline like this to sort of generate visualizations. And so going forward on the interface, you could either select a data set, or we could use one of the existing links that are available. In this case, we'll look at the SP500 data set. Okay. And I thought I had this cached earlier, but looks like if we're doing a full brand new call. So let me see if I could. Okay. Let's see. Of course, demos always have like a bit of this effect. Let's just take a look, ensure our server is running, and do a couple of back checks. And so while this is spinning up, I'll sort of talk through the pipeline. And so LiDAR sort of structures visualization generation as 4 main sections. In the first section, once we provide our data, we have a summarization module. And the goal of this module is to ingest your data and come up with a natural language representation of the data that the model can use for every subsequent task. So there are a couple of things to keep in mind here. The first is that our data might have arbitrary size, tens of thousands of rows, millions of rows. And so from that perspective, we want a representation that is compact, is natural language, but at the same time, it respects the limited token budget for LLMs. Let's just do a quick refresh here. Select our model, GPT Turbo. And so One other thing I'd like to point out with LiDAR is that it supports multiple LLMs. In this case, we could use OpenAI LLMs, models from Google, Palm, Cohere, Hugging Face, and it's sort of designed such that the LLMs underneath are switchable. And so, yes, we got things running now. And so in this case, once we selected our data set, it gets passed to the data summarization module. And summarization is done as a two-stage process. In the first stage process, we take all we know about visualizations and we come up with heuristics for the data. So in this case, we might try to use a tool like Pandas to sort of extract the atomic type for that field. And so in this way, we've sort of discovered that the atomic type is Date. We can compute the mean and the max for that field if it's a numeric field. We can construct a list of non-null samples from the field. We can compute the number of unique values. And then once we have this Bayes representation for each column in the Bayes set, we can then give that to an LLM to sort of annotate or embellish or enrich that representation. And in this case, we ask the LLM to predict the semantic type of each column. In this case, it's a numeric field, but it's also date. And also we ask it to come up with a description. And so in this case, it says the date of the stock price. And the core idea here is that if we have this rich representation of our data, then we can then pass that down to subsequent modules. And so in the next module, we have the goal exploration module. And the core task here is to come up with potential visualizations that make sense given this data representation. In this case, we structure it as a multitask prediction problem where we ask the model to predict a hypothesis, a question. We ask it to come up with a visualization title, and we also ask it to come up with a rationale for why this visualization might make sense. So you might have heard of chain of thought prompting, such that where we sort of structure problems such that we ask the LLM to sort of provide like justification for its work, sort of think step by step. And once we do that, we get much more semantic or correct responses from an LLM. And so here the model has come up with about 5 different like ideas. And so automatically it takes the first idea, what is the distribution of stock prices? And then what it does is that it generates code that addresses that goal given the data summary. We compile that goal, we do some error correction, some pre-processing, post-processing, error recovery, and then we present a visualization to the user. We can do that for all of the different goals that the system has come up with. And in the case that any of these goals just don't meet the user's requirements, the user can always come in and type, sort of describe their intent, and then click generate, and the system will about do the same thing. Next, for each generated visualization, we can then dig in and do things like, let's say, convert this to a bar chart. And so ideally, the goal is that the system takes the representation of the visualization, the code we have here, it takes the additional instruction, and then we go through the same process, we generate new code, we compile it, and then we show that to the user. So previously it was a line chart, and then now we have a bar chart. Of course, we can see that there are some mistakes here. The system is not perfect, and so we can see that the x-axis is sort of cluttered. And so maybe we might ask the system, the x-axis is cluttered. Can you go back and sort of fix this, make this more legible? And the system will actually do that. Another thing that comes up when you put a tool like this in front of users, and so the user might have the curiosity and interest to sort of come up with good things to ask the model to do. But however, they might struggle sometimes to sort of judge the correctness of the code or the visualization that has been created by the user. So from that perspective, you could use the system has an explain feature where we could ask the model to sort of walk through the code that it has generated and sort of post hoc or retroactively sort of explain what it has done. And so in this case, the system starts out with an accessibility description of the field. Says this is a bar chart created with Seaborn, and talks about the size, talks about the axis, and just the physical appearance of the chart. And this can be super useful for accessibility of building accessible systems. Next, it talks about the sort of transformation that was applied to the data. It says here that we've converted the date column to a date type using the pandas to date function, and that errors are handled in a specific way and null values are dropped. Next, it also describes how, and for each of these descriptions, it sort of pairs the code that's associated with that. And typically in some use cases, I've seen situations where the user sort of reads through the description of what the code does and then might go back and retroactively sort of modify the request or the make changes to the to the charts to sort of address those goals, those mistakes. And so another thing that you could do with a system like this is that let's say we go back and we say like convert this to a bar chart. We could also get the system to sort of self-evaluate itself. And so in this case, we could run this as a self-correction or error correction module in the background where the system could retroactively look at the code that it has written and sort of evaluate it across multiple dimensions. In this case, we select the dimensions that are used to evaluate the code that was generated. And this is all from research on like visualization generation. But let's take a look. So on the first dimension, it says there are no bugs or logic errors. It says that no additional data transformation is needed. Compliance here has to do with how well the generated chart meets the goal that was specified by the user. And so it says that the code here meets the specified visualization goal. However, on the type dimension, it sort of rates the visualization of 4 out of 5. And it says that the bar plot is an appropriate visualization here. However, a line plot might be more effective. And so you see these sort of suggestions. Let's say you use the pie chart. The system might say, okay, a pie chart is better just because it allows just better visual comparison of quantities. And so it turns out that like large language models like GPT 3.5 and above, they're quite good. They have very, very broad world knowledge, and they're able to sort of encode visualization best practices. And the goal here is to sort of figure out the prompt structure that helps us apply all of that knowledge in just creating good visualizations. Now we can click a button that says like auto repair, and then sort of repair that chart. And so here it just reverts back to a line chart. And then finally, we can take the same approach, given some code. You can ask the model to come up with potential recommendations of visualizations that make sense. And so based on this, we just ask the LLM what are other visualizations that might make sense given this that the user might be interested in, and the system will go ahead and sort of come up with potential visualizations. In this last example, it shows like a kernel distribution of stock prices over time. Okay, and so this is just a very fast, high-level walkthrough of a demo, a concrete realization of how we might take LLMs and pair them and sort of integrate them in the process of generating visualizations. I sort of skip over the infographics part. That is still much work in progress, but I'll sort of get back to that during the rest of the talk. One final thing is that we could select different visualization grammars. And so in this case, we just have 4 here. In theory, we could select visualization grammars from other programming languages and sort of integrate that into a common workflow. Okay, and now I'll get back to the slides. So in terms of system components, I mentioned earlier that there are 4 high-level components that sort of make the system work. The first is a summarizer. So the summarizer ingests the raw data and sort of has this 2-stage process where we use our understanding of just data analysis and visualization generation and come up with like a representation of the data set. So compute things like min, max, number of unique values. And then we can take that representation and give that to an LLM to sort of enrich it with more semantic fields like semantic types and description of each field and the entire data set. Now, once we have that, we can have that as some sort of grounding context for every other activity that we ask the system to do. So for example, when we ask the system to come up with goals, essentially what we're doing is that we're asking the LLM to take the position of a data analyst, sort of come up with potential visualization goals that make sense for the data. And so the LLM is able to do this because it can ground all of its explorations or its generations on this summary that we have generated for the data. Next, we can have this module that generates, explains, evaluates, and repairs code. And essentially, that's what sort of powers the visualization generation. And then finally, there's an infographic module that's optional. And what that just does is that it uses a latent diffusion model and does just image to image generation, but conditioned on some style text, some style prompts. And so here we have a bar chart, and we sort of condition it on skyscraper text, and we just do image to image generation with a low strength parameter. Of course, you want to use a low strength parameter just to make sure that the output sort of conforms, sort of maintains the structure of the input data set, but at the same time yields more interesting and more aesthetically pleasing infographics. And so that is the core of each of the different modules. And so I will share a link to the repository for this project. And I think the most interesting thing there would be to look at some of the prompts that are used to sort of construct the prompts for each of these modules. And so the summarizer creates a natural language summary of the data. And so here's an example of what the prompt might look like. You're an experienced data analyst that can annotate data sets, always generate the name of the data set, generate a field description. And here's what the output looks like. Next, there's a goal explorer. And so here's what the prompt might look like. You're an experienced data analyst and a visualization specialist. And more importantly, we sort of make some requirements on the structure of what it can output. So I mentioned earlier that for each goal that the system generates, it has to come up with a question, a hypothesis, a visualization title, and also a rationale for why that visualization makes sense. And then finally, the Viz generator module takes in a goal, takes in a summary, and also it uses a code scaffold. And so, for example, an important distinction here is that we don't just ask the LLM to generate visualization code. Instead, we provided a code scaffold where we have like a plot method, and it's rather than generating just code freeform, we ask the model to sort of fill in the parts of the scaffold. So this becomes very, very important to ensure reliability. And then the infographic module is optional, but the idea is that like we take valid visualizations, we pass it through a latent diffusion model, and then we get stylized versions of those base visualizations without compromising much of the structure. And so I'll skip a little bit of related work and I'll go into evaluation. And so naturally, there are a few issues that come up with evaluation. The first is that LLMs are stochastic and bugs might occur, especially when we're trying to generate code that compiles. And so we need some sort of measure of reliability. Next is we might be able to generate code that compiles. However, how do we sort of continuously measure visualization quality? And then finally, there's always a challenge of memorization. So how much of the output is based on what the model has seen during training, as opposed to it being able to sort of extract parameters of the task at hand. And so to sort of measure reliability, sort of propose visualization error rates. And so in this case, we have over 2,000 visualizations generated based on about 50 data sets from the Vega data set. And so for each data set, we asked the model to come up with 5 visualization goals. For each visualization goal, we asked the model to generate visualizations across 2 grammars. And then overall, we sort of measure like what percentage of times do we get like visualizations that just contain like compile errors. And then and so the charts we have here is just a small ablation study that sort of shows that like when we include just the schema as a summary, and so just a list of the tables in the data set, we get about a 10% error rate. However, when we actually include all the details we have in the summary, and so we include like just the properties of each field, and in some cases we sort of enrich that representation using semantic types, we get much lower visualization error rates, and so down to about 3.5%. Next, I also showed the ability of a model to self-evaluate code across multiple dimensions. And so we can use a much larger model like GPT-4 to sort of compute the scores and so as a way to sort of evaluate the performance of smaller models. Okay, so in conclusion, there are 4 high-level lessons I think are sort of useful here. The first is, of course, I think, and I know that Alan sort of hinted at some of these. If you ever have a problem where you know the structure of the solution, as opposed, and that represents your domain expertise, as opposed to having the model sort of solve all the problems, is a great idea to sort of separate the parts of the problem that you sort of understand and bake that into the generation process. In this case, we rather than letting the model generate the entire code for the visualization, we sort of use like templates for each of the different languages we're interested in supporting, visualization grammars we're interested in supporting. Another way to do that is to also do things like 2-stage summary generation. So we take all we know about like generating representations of data, and then we can then give the LLM to enrich that base representation. And then finally, structure the problem such that we minimize latency. So every single step is a single call to the LLM. Then finally, designing evaluation benchmarks has been critical just to sort of tune the scaffold, tune the prompting system, and sort of ensure that the overall system is getting better. So some future work, there's still a lot of work to be done. There's a lot of opportunities to improve the reliability of the system. There are still cases where the system might not just come up with visualizations that are valid. There are differences in behavior across models, and so the best performance you get from really large models like GPT 3.5 and 4, and with smaller open source models like 7 billion and 13 billion parameters, the error rates are still very, very high. So this is like an open research direction. And so from that perspective, it makes sense to look forward to sort of explore ways of sort of tuning or fine-tuning smaller models such that they can approximate the behavior of larger models for these sort of capabilities. So at this point, I'd like to stop and sort of take questions if that works. And while I'm waiting for questions, of course, there are limitations to this approach. The first is the more representation the visualization grammar has, the better the performance of the overall system. And then also, this entire like application or system requires code execution, and it's important that all of this runs in a sandbox environment. So, Noble, did you have a question?
Oh, yeah. I asked it earlier. But great presentation, first of all. I'd love for you to share any trade-offs, challenges you had to make. For example, having the model sort of self-evaluate, that seems like a challenging proposition.
Yeah, so ideally, you want a human evaluating the subjective quality of the visualization. And so that typically is the gold standard. But in most cases, you just didn't have that as skill. And the next best thing you have is to have a really, really capable model like GPT-4 sort of take on the persona of an expert and sort of evaluate models across multiple dimensions. Of course, clearly, the performance of GPT-4 on that task of like self-evaluation is significantly better than even GPT 3.5. And then when you start getting down to the Llama style models, like you just can't use Llama style models for this sort of self-evaluation. They just don't work. And so it's a trade-off. In the absence of gold standard human subjective evaluations, the next best thing is GPT-4. And the other reason why these sort of signals are good is because they can be a good way to sort of approximate human behavior when you want to, let's say, fine-tune smaller models. So let's assume that you had like a 13 billion parameter model and you wanted to sort of fine-tune it towards just better capabilities across all of these dimensions. And so the next best thing to do would be to sort of distill GPT-4 behavior, its evaluations across these dimensions. And so you can use that as a filter on the kind of data, data that's used to fine-tune these small models. And this is an ongoing sort of area of research. So, great question, though.
Thank you.
Thank you very much, Victor, and amazing talk there. And next up, I believe we have Noble Ackerson, and he'll help us understand the challenges and solutions when implementing LLMs in enterprise contexts. Thank you, Noble.
Hello, and thank you everyone for investing your afternoon. I hope everyone's learning a lot. It's been a phenomenal set of presentations so far. Peter Norvig helped us understand how these things work. Alan gave us some insights as to how to talk to these to generative AI solutions. Victor just now sort of showed us a practical example of how showing the power of these tools, and I'm going to sort of just take a beat, a left turn, and sort of show how, in an applied sense, we're also using these tools in the enterprise. This talk, if the title sounds familiar, is from a towards data science publication that I wrote in February. And so we'll jump right into it. And thanks again for the organizers and everyone involved for putting this together. All right. So to get to done in about 30 minutes or 20, you'll be taking away why unreliability of these generative AI systems erodes trust in the systems that we build with generative AI. It's an opinionated take. From an enterprise context, I want to show how these systems are used. So it's a field report of some sort. I'm going to then sort of use examples to share why these systems behave the way they do and why they're unreliable information sources and stores. And then, of course, share what is being done about that, at least in the context of my line of work. And so I will, of course, leave some key takeaways and some links and resources at the end of the talk. And I hope to post this slide when I'm ready to share it. All right, so generative AI tools, we've heard a lot about them today. They're, large language models, super powerful, right? There's a chance that these tools will be ubiquitous or ambient in our lives, if they're not already. The notion that based on how they work, that an autoregressive system that lacks a cognitive architecture or deductive reasoning, the notion that these things are blind to what they know and what they don't know, those would be incorporated into consumer like search, for example, actually terrifies me and continues to terrify me because of the world that we live in with, misinformation, disinformation, that kind of stuff. And this is a concern for enterprises, right? And so in my opinion, generative AI will always be an unreliable store. These systems are improving though. And so as you can see on the screen, one of the first things I do with any new state-of-the-art model, this was back in February, I ego surf. I Google myself of sorts and try to find out what the system knows about me. It's a very egotistical practice, but what way to evaluate a few shot or zero shot approach to testing a response by searching for something that you know a lot about, which is me. And so back then it told me I was dead. I was a successful entrepreneur that actually died. There are some half-truths in there, and that's almost a blueprint for misinformation if you do not know what you're working with. And so that's why it sort of frightens me to be tightly incorporated into search. But joke's on you, ChatGPT. at least the earlier version of it back in February, because I'm still alive. I think I am. I'm the director of product at Venterra Corporation, which is a technology firm in Northern Virginia. And I work with federal customers, try to be responsible in how we incorporate data and AI models into production applications to help U.S. taxpayers every day. On my personal side, I also run a company called Byte and Atom Research, where I work with mid-sized enterprises to help them think through their data trust strategy. And in that, I'm just focused on bringing reliable, trustworthy, and responsible data governance to applied learning context. So Byte and Atom Research is essentially an applied research firm, applied research and development firm. And so that's about me. This stuff that I'm about to talk to you about today is what makes my heart sing, right? I want to be a great ancestor to these ubiquitous tools, tools that are eventually going to be ambient for me, my children that you see here, and you, right? So let's dive right in. As I was listening to all the previous talks, I started trimming back my slides because it was well covered. And so I'm going to sort of breeze through some slides, so I hope you don't mind. And for the rest of this talk, I'm going to be intentional when referencing foundation models or base models versus generative AI or GPTs, and try to focus the conversation on large language models in an enterprise context. Normally, when I do this, I sort of separate sort of external LLMs, which our enterprises have no control over, often, API only access type models like Cohere, Anthropic, and some of the offerings by Google Cloud Services and Vertex. And then you've got your, internal LLMs like, Meta 2, and which, if you've been following on Tuesday, Google Cloud announced was now available or would be soon available in the model garden that I believe Alan talked about as well. So that's great for the types of customers that I serve. Foundation models, put simply, are trained on a ton of data. I'm not going to go into too many details because just watch Peter's talk. They can be further tuned by the time you receive it for specific tasks. So you've got, Palm 2, and then you've got MedPalm for specific tasks for medical applications. And really briefly, how these base models, these foundation models are trained. They're trained on academic corpus, and so we're talking legal documents, patents, medical journals, general internet scraping, or crawling the web for Reddit and Twitter and pretty much any other service provider that is now locking down their APIs. That was a joke. Project Gutenberg. So we're talking like books and novels and code repos, Stack Overflow, math, YouTube media, that kind of stuff. And so foundation models can take the form of text, images for audio synthesis, videos like what Runway is doing, stable diffusion for images and that kind of stuff, right? In some cases, like with Bard, you might mix two modalities together and you'll get a generative AI solution that leverages, computer vision and the power of, large language models as well. Okay. I promised a field report of some sort. So here, the end result of, the technologies behind large language models or foundation models are very useful in the enterprise. I bucketed them. This is not exhaustive. They fall into information retrieval, automation and efficiency, content generation. And to date, since I sort of jumped into generative AI, I've seen impressive demos. I've seen I've built some of them, and they always sort of wow the room, and everyone gets that fuzzy feeling as to the power of these tools. But in an enterprise context, the cost for an enterprise to ship a generative AI solution without consideration for factual correctness, repeatability in development, consistency, and reliability is high enough to require guardrails of some sort, tests, safety mechanisms, automation for reasons we'll get into. But before then, let's talk about some ways that these systems can be unreliable, because that's provocative. It gets you going. That's why you're here. There are lots of reasons. I've cut out a couple slides that sort of go deep into this for time, but I'll boil it down to 3 things. So I'm breaking down my thesis. What really inspired this talk, like I was talking about, was my fear that generative AI was going to be incorporated into search. So I'm going to use that to sort of frame my argument here. People look to search engines for fact. I don't care what you're doing, right? I typed in Noble Ackerson in Google just to see if there's anything. So try Googling yourself. You've done it a million times. I'm not the only egotistical person in the room. And if you find something inaccurate, guess what? There's a whole industry aimed at fixing errors on those links. You can't do that easily with a large language model. So left unchecked, these probabilistic, stochastic nature of Gen AI could lead to more misinformation, disinformation, and societal harm. Yes, I know that these systems are being improved, and there's some UI tricks and user experience techniques that, say, for example, Google's new search experience is introducing, where it's very smart as to when it uses a Gen AI response versus when it filters down links for you. And I think that's very innovative. And so these issues are boiled down into probability. Again, there's some element of randomness in how these systems, before you get a response, are rewarded based on making the best guess on the tokens that came before it, and also ultimately based on the data that they're trained on, right? So prompt design, and I'll get into this at the end of this talk, is very critical. You put in a garbage prompt, you'll get sexist, racist, and toxic responses out. And Alan was really good at explaining all of that. There's also knowledge gaps. Quite famously, OpenAI talks about how their models were not trained past 2021 September, right? And that's important, because when I go in and I type into some of these systems, what is an LLM? Believe it or not, even though these systems are powered by LLMs, it will not know what an LLM is. Sometimes it might get it right, but most of the time it'll get it wrong. They also overfit, right? Which means the responses have a behavior that repeat the exact copies of the text that they were trained upon, right? And that leads to situations where Sarah Silverman, a comedian in the United States, might sue a company. So imagine if you're this little startup building your Gen AI tools, and Sarah Silverman comes and says, "You've just ripped off my entire book. You're out of business," right? And so enterprises are very, very cautious. And when I talk to them, they understand that in some cases, they may not have full control over these systems. So they come to someone like me to sort of help them think through ways to solve these problems. And so with that, let's talk about what to do about it. I think I'm about 15 minutes in, so I think we can get through this. Before I go on, though, I want to stress that we've heard a lot about large language models, and we're seeing so many innovations with large language models, but a model is not the product. Let me repeat, the model is not the product. The Gen AI, the generative AI solutions that you integrate into real software to solve real problems is the product, right? And so I'm going to zoom in into this framework that I designed for my customers, where these are essentially checkpoints, where you have your data input and your system input, where you're looking to mitigate any potential issues in your data inputs, your actual pipeline in order to sort of solve the problem. There's some evaluation techniques that you need to do. We'll take a look at that. And of course, if you sort of include experts to sort of review the outputs of these tools, as Victor was talking about before, there's some techniques that we'll go over. And so with this in mind, I'm going to be zooming in and out of every single one of these, hopefully in about 10 minutes. All right. So, you've built your fancy demo, you work for corporation X and you're solving a specific problem and you built your tool. There are many paths to tame the unreliability, and let's define unreliability for the sake of this conversation as factual correctness, right? There are many ways to sort of tame it. And so I designed this framework to help my customers sort of think through what they need to do to adapt their existing machine learning operations pipelines or sort of build new ones to help sort of rein in the uncertainty with outputs in these systems, right? Again, I have the word fine tuning here, which you've probably heard a lot about. Fine tuning does not teach your models new knowledge. The goal of model tuning or fine tuning is to further improve the performance of the model for a specific task. So, you know, even with that MedPalm example, once you start integrating it, you can actually fine tune that on top of you know, fine tune that against your private data against that large language model. Okay. And so again, back to that system, so we can actually zoom into the data input and the system input and the system output. Okay. Again, lots of hype. Seen some impressive demos with LLMs, but again, they fall over the instant someone tries to use them within an enterprise context. And it's pretty tough to sort of rein in these things. So we're going to sort of zoom in further into, you know, the data preparation part, the fine tuning if you need it part, testing and deployment. Then we'll move next into your application pipeline, which is often a streaming pipeline. All right, so you can imagine this architecture being applied if you do choose to use you know, GCP to host it. It works similarly. You just sort of swap in available services within that ecosystem. Okay. All right. So in practice within the enterprise, you know, they're bringing in their domain-specific data sets. So help desk has, you know, chatbot data or conversations, reviews for their tools. Those are domain-specific data sets. For, you know, I've got feedback data here, which is not necessarily RLHF, which is reinforcement learning with human feedback. That's actually different. That's a mistake. But this feedback is literally from your users, right? So to give your model that improvement flywheel. So for example, incorporating ratings or comments on generated text quality to improve your model's behavior. That's why you have that. And then lastly, there might be more for you, but you know, data from your security and safety team, so logs and previous red teaming example to sort of augment your red or purple team's activities to further make your system a little bit more robust to adversarial attacks, right? And so then I'm going to get into further detail, but what I want to highlight here is, you know, one big checkpoint, another big checkpoint is your evaluation. Another big checkpoint is, you know, how you test this before you have your application pipeline ingest this. And when things are not right after your testing, you know, you have a redeployment trigger using your, you know, cloud build, or I'm sorry, your CI/CD pipeline of some sort. All right, I forgot to mention for your data versioning, you might want to use DVC or data version control or whatever is equivalent in your environment. All right, so now you sort of served your solution. You want to ensure that you have reliability checkpoints along the application pipeline as well. Alan talked about that a little bit, but let's sort of briefly look at, you know, an oversimplistic tool sort of pathway. What I'm going to focus on is mostly some of the techniques to ensure reliability, and very next I'll sort of show you one example. Some people use embeddings based on data that is uploaded, or it might use a database, or probably use an agent where it's basically an API call. So essentially your generative AI solution becomes a, sort of smart with sort of crawling, you know, accessing a predetermined system that has a RESTful API already on there. Of course, with all of this stuff, you need feedback loops for your team, and that normally gets stored in Feast or whatever feature store that you may have within your ecosystem. But as part of that whole flow, your user makes a request, goes through some magic, and which Alan has talked about, and you get a response back. One emergent technique this year in making generative pre-trained models reliable, especially in the enterprise, even though it's not foolproof, and I'll explain why, is something called retrieval augmented generation, or RAG. And for the past few months, a bunch of novel approaches to help tame these, the unreliability of these models have come through. And in simple terms, a RAG is a technique to update the AI's knowledge, right? Or I flipped the last image that you saw, vertically so that or horizontally, so you can sort of see it from the sort of user's standpoint as I go through this. So again, sometimes you may want to add recent external knowledge. Say, for example, some of my initial demos for my customers were just semantic search example or sort of a RAG example, without consideration that, within the enterprise, new data, new knowledge is being added to a knowledge store every minute, right? And especially in larger organizations. And so you need a pipeline to sort of scale your data store at the end of this stuff. And so a retrieval augmented generation pipeline is very important. And sometimes, depending on your ecosystem, you may have some tooling to sort of stitch this together. There's some open source solutions out there like Llama Index or LangChain, as was talked about before, to help you sort of stitch all of this together so that when a user makes a request of your system, you're able to get the latest and freshest information in order to give them a factually accurate in the way that we're defining it for this talk. But it's not a silver bullet, because there is, if you're fetching real-time data from a database using, Postgres or, a PG vector, one of those types of tools, there's going to be latency. You have to do some checks. And then I'll also talk about other techniques there in a second. I just want to sort of speed up a little bit for time. There's data quality issues. Now you're allowing this massively powerful, galaxy scale trained LLM to only to adapt its knowledge onto your private data, right? So if your data quality sucks, well, you're going to get more inaccuracies. So that's a drawback. There's complexity in there because, we're talking about LangChain and Llama Index and this thing and, ABAC and RBAC and all that stuff. There's going to be complexity, and with complexity comes cost. So I've walked you through the data input, the system input, the pipelines. Now let's talk about the system output and the product output, right? So for data, you want to you've employed methods to sort of address hopefully missing or inconsistent data. You put in a pipeline in there. You've added a little bit more complexity, but now you're starting to work on sort of the application pipelines, how your system interacts with humans. And I love Alan's talk, not because we're friends, because it sort of helps me sort of cut the corners as to how to make these things reliable. So what I swapped some of my code slides with was something that I'm researching for a book that I'm coming back with, which is the importance of talking or speaking to these systems. I believe Ilya Sutskever of OpenAI said, the most powerful programming language is English. And so this is normalized that to say is language, just to be more inclusive. But language is hard. Conversation is hard. And in the late 60s, a philosopher called Paul Grice identified something called the cooperative principle. And he's a well-renowned linguist. And so one thing that I want to sort of leave with you is sort of think about some of the lessons that he taught when you're sort of crafting your system from a developer experience, or just sort of things that you want to account for when you're evaluating how your users are interacting with your solution from the CX, or this customer experience, or the user experience, right? And so Paul Grice talks about 4 maxims, right? He talks about quality, quantity, relevance, and manner. For quality, we want to talk about, he's focusing on how truthful we are. For quantity, he's talking about how informative we are. There's relevance. And with manner, he's talking about how clear we are. And these can be used as sort of reliable guidelines when you are doing your in-context learning or prompt engineering, and on how you sort of frame your prompts. And so, when you want to put a simple example, overly simple example, when you sort of want to sort of train it to sort of say, tell me about AI, that may, for, the quality or even the quantity maxim, you may want to sort of think of something like being a little bit more illustrative, like, explain the key principles of machine learning, and just sort of provide it with examples, as Alan and Victor were talking about earlier. So this aligns with your model's in-context learning or prompt engineering abilities, allowing it to generate more targeted and useful information. Another technique to sort of rein in, what you may not be able to control, right? Note what I'm doing here. You weren't able to control the inputs, right, with your data, with the interacting with a large language model, but we constrained it and made it a little smart with things like RAG and vector databases, that kind of stuff. And then how your users are going to work with this thing also is a little unpredictable. You have no control over it, because you can account for 99 different scenarios to sort of protect your system. I guarantee you launch your app and you ship and you pop your champagne, they're going to find 101 way to break your system. Right. And so there's tools like guardrails that allows you to add structure, type, and quality guarantees to your large language model outputs. And because whoever came up with guardrails is super smart, the Rails part is called reliable markup language. And there's a guardrails, getguardrails.ai is one. This image here is from NVIDIA, who recently launched Nemo. And so you're using these Rails languages as sort of a buttress for your solution to define things like the data types that your users are going to be interacting with, corrective actions, to validate and correct LLMs before generating a response. So you've probably heard how other LLMs do it. When you're using it, it says, as an AI, I can't talk about politics. So think about those types of solutions as well. Let's land this plane. So to land this plane, we talk about some key takeaways, right? We've talked about, your data inputs, your system inputs, your system outputs, and your product outputs. Here are some mitigation techniques that we look at: robust metrics and security measures for the data input, task decomposition, feedback loops, guardrails or defensive UX for the system IO. And then, of course, product output has, I want to sort of go back to, I cut out a slide here, but you want to sort of properly explain or clearly explain what your system can and can't do. And then, allow your users to opt out or, correct, any issues or give you feedback as you're going along. I won't get into this too much. I think I'm at time or maybe close to it. And so these are methods for reliability and some continued research. You will see some of this data come out over the next couple months as I sort of get close to publishing my book sometime next year, if I get time. And I want to leave you with some resources because, why not? I will make these slides available. There's a lot of interesting work, research that you can apply, and I'm going to make that available for you. That's my gift. And yes, we can conclude, how we test our prompts, how we sort of put guardrails around our systems. Regardless of what we do, that conversation with the machine is very important. So it's worth revisiting, linguists and just sort of mapping some, being a creative technologist, sort of map some out of domain context to what you're trying to do when having your users converse with your generative AI solution. And that is my talk. If you want to read about the full context of my talk, it's a short read and it's going to be on my Medium. Sorry for shilling so much. And that's it. Thank you. Questions. Let me see. Try to pull up my questions here. Oh gosh. Let's see. Is there any standards for testing the capabilities of LLM based on task types? I think I may be wrong here. I don't know this answer to this question, but I'm going to go on a limb to say we're in the Wild West where there are no standards yet. There's some good best practices. If you sort of look at some of the resources that I provided, evaluation using benchmarks, publicly available benchmarks is one. At some point, you notice I had A/B testing. So depending on your use case, you may want to get experts if you can afford it to help you evaluate or test the responses in your system.
Excellent presentation, Noble. Just a quick question. And so in implementing RAG, so retrieval augmented generation, because one of the challenges that I see is that, like, especially when you try to do it, is it's in some cases it can actually hurt performance. And so your ability to retrieve the right documents sort of has this outsized effect on the sort of value you get overall out of that whole experience. And so, like, do you tend to see things like that? Like, how often do you see challenges like that sort of coming up, just in general?
There are tons of challenges, and I think I scratched the surface. So I cut a lot of slides back. I also have a similar example with semantic search. So I'll be talking about this a lot this fall at Voice and AI, actually with Alan. But to your question, outside of latency, data quality, complexity, and cost, there's also security risks. So fetching data from external sources some can potentially pose security risks like data breaches or unauthorized access, if that sort of goes to your question. And so you have to add more complexity, right? Yeah. You have to look at role-based access controls or right. attribute-based access controls and sort of incorporate that as well.
Yeah, great. I think that's a great point, because you don't want the LLM answering questions using data that user should not have access to. So
right.
Yeah.
Right.
Cool.
Yeah, I didn't have time to get into all of it, but you're absolutely right. It is a nightmare, especially when you have, one good question that I got from someone who knew nothing about the system. They were impressed at the demo, a construction firm that I helped out. But then they go, so what do we do with our Postgres database in our systems? Because it already has all those checks, all those sort of gates where they have an ABAC sort of protocol in there, not just based on the role of the user, but certain attributes that should be exposed to the user. Well, none of, and of course my response was, well, this is a demo. So,
yeah. Great. Thanks again for your presentation.
Awesome. Thank you both. And thank you so much, Noble. We are almost at the end of our session. So this is our last session with Maddie. So we're going to talk about open source AI. Maddie.
All right. Can people see my screen?
Do you want to turn your camera on? Or?
Nope, I'm good. The room is a mess. So, awesome. So, really excited to join today and talk to you a little bit about open source AI, why I think open source AI is the future of AI, and how you can get involved. So, let's start with a little bit of a question. What do all of these things have in common on the slide here? And I want to see answers in the chat. Okay, and if you've been working in machine learning for a while or AI for a while, you will know that these are all key libraries and packages that we use daily as ML practitioners, and they're all open source projects, right? Recently, there's even more indication of commercial success. For example, the acquisition of Databricks and Mosaic, and also recently the funding round, with Hugging Face. Really excited for that team. Congratulations. So clearly, open source AI is working, right? So little bit of introduction about myself. Who am I and why do I care so much about open source AI? My name is Maddie Shang. I'm a research engineer and team lead. I've been kind of doing ML R&D in industry for about 6 years now, but I am most proud of my work and contributions, and I'm most passionate about what I do in open source AI. So, I actually started my career as an open source contributor after pivoting from venture capital and finance, teaching myself how to code. It's how I got my first position as a software engineer, and subsequently I was able to use open source to explore the fields of blockchain and eventually really dialing in, focusing on AI. Right. Since then, I was able to build a number of useful things. I was able to contribute to ML research and pushing that ahead, and I was also able to create access to opportunities. So I am also built by open source. So I want to take a moment and share some of the cool projects I've had the honor and opportunity to, get involved in. One of them is Women Who Code Data Science. This started in 2019 after I landed, one of my first, real ML engineering jobs. And the intention was that in the process of becoming an ML engineer, there were a lot of people giving feedback, such as, hey, you need to go get a PhD, or this is going to be really difficult for you, or don't think it's going to work out. And the moment I realized, oh, I actually figured this out, I really wanted to essentially provide a pathway to make other people who are trying to do the same thing have an easier time. So this is a community that I grew from just myself to over 2,000, within a year. And it's continued to grow since then. We are offering a lot of open source material on, the basic statistics, how to write your first line of code in Python, all the way to advanced natural language processing. So really cool project, and you should consider joining. Here's another really cool project that I had a lot of involvement with. So this is a project called Sift. This was actually the first cross-platform for federated learning that runs in the browser, on iOS devices, and also on Android devices, and of course on the server. So as part of this project, I was able to contribute to research, and we presented at ICLR 2021. And after that, I started to lead a team within OpenMind called OpenMind Rexis, stands for Recommender Systems. And as part of that team, we built a differentially private browser and a prototype. So what it does is that it's able to look at the data that's stored on your local device to optimize user experience and also personalize it, right? Without that data ever leaving your device, and hence preserving your privacy. So here's a very quick demo of animation or GIF. It's hopefully starting it sometime soon. Oh, sorry. And it's basically showing you the browser doing some differentially private federated learning computation in the backend and kind of adapting the UI according to your preferences. And the next project is the learning team beta bootcamp as part of OpenMind. This is spun up to essentially give people access to knowledge and skills and kind of foundations of building privacy by default products and privacy preserving machine learning. And this has since then spun into OpenMind courses. There's a lot of really good material here produced by industry experts. So if you're curious about machine learning, privacy, how it affects you, feel free to take a look. And lastly, a more recent example of how open source AI education is able to kind of help people create opportunities and improve their careers. This is I was kind of asked to lead a machine learning certification program offered by Google that leads to a professional ML engineer certification for NYC. And as a part of that process, we were able to work with over 100 people, studying for their certifications, right? And I wish all of them very much good luck and fun in the process. So all that is to say, I spent a lot of time working in open source AI, thinking about it. I still don't know what I'm doing, but I have a lot of data and a lot of experience that I could potentially share with you. And it is my conclusion that AI is uniquely suited for open source for the following reasons. One is that training AI has a lot of potential and a lot of benefits, but it also has a lot of cost. And some of those costs are what we call externalities. These are unaccounted for, right? Therefore, AI is best treated as a public good. Also, open source AI is able to improve alignment, access. It is fluid. It's efficient in resources, projects and experiments are spun up and shut down all the time. And therefore, it really improves transparency, trust, and reduction of risks, right? And I'll talk a little bit more about this later. And finally, even if you didn't really care about the first two and you're just purely here for effect, open source AI actually gets you really far. It is one of the lowest cost, most effective ways, even for real enterprise use cases, and we'll walk through one of those. So some of you know me knows that I spend a lot of time in the wilderness and living off the land. And recently, there's a lot of wildfires and kind of extreme weather events due to climate change. So I got thinking, how much is the impact of training a large language model? And the results really was very sobering, right? And the other thing I know is that there's a lot of communities, especially the indigenous communities, doing climate science, climate data science, doing experimentations on prescribed burning to prevent wildfires. They're very successful, and they've been doing that for thousands of years. Now, if the data science and machine learning community does not have equal and fair representation, how do we get to learn from their experience, their wisdom, and how they do data science, right? So this is kind of my quick illustration of why the first 2 points kind of matters. And then let's look at an actual example of us doing machine learning in enterprise settings using open source data and open source models. So here's kind of the problem setup. We have a bunch of tabular data, and we're trying to help users who are maybe domain experts but not technical experts answer questions and generate visualizations using their data set, right? So for example, a question might be, what is the best-selling product with low risks? And after the query hits the table, it's supposed to generate visualization that answers that question. The problem is we didn't have very advanced models at the time, and also we didn't have any proprietary data to train the model. So the only option we had to pursue this project is to start with open source. And that's exactly what we did. So here is what I call the large language model R&D ladder, right? We start de-risking by using the simplest things, and then we gradually increase the complexity and going all the way from few-shot learning to end-to-end fine-tuning, right? But the first thing we did is actually ask a API and say, hey, can you tell me a business story? And the intention of doing that is we wanted to see, do pre-trained language models at the time have enough business context? It was able to produce a few articles that at the first pass could have been, something that showed up on Bloomberg News. So we're pretty okay with that result. So then we went to do what we now call prompt engineering and context engineering. So we asked questions like, can you give me a list of business KPIs and metrics, such as return on investment, net asset, net profitability ratio, and things like that. And it was actually able to do that as well. So basically, this tells us that pre-trained language models actually have enough information to handle our specific business domain. So then this kind of earned us enough confidence and willingness to get the resources to proceed with what we call few-shot learning, right? So in few-shot learning, the idea is when a user starts to ask a question, starts typing into the search bar, frequently they know how to start a question, but they don't know how to end the question such that it ends up with a successful visualization. So could we actually, get a human expert to give us a handful of examples and then train a model to basically mimic the generation of, a complete natural language query that would end up with a successful visualization? And then this is exactly what we did. So we were able to use a T5 model that's open source. We're able to train this using free compute using Google Colab. And also, we got basically, this is the only data set that we have that we provided to the model. And the results actually came out pretty good, right? It's able to essentially generate similar kind of ways of ending inquiry. It did, kind of mess up a couple times. It said, average profits on average, which doesn't make any sense, but the rest looked good. So after a little more kind of fine tuning of this model, we're like, okay, let's move on to the next step and do a little bit of end-to-end training, right? So then the idea became, if we're able to generate valid proposals and the user keeps typing, but maybe the user is typing in a way that isn't typically very, machine learning friendly or business context friendly, how do we solve that problem? Could we, look at what the user is typing and then look at the list of proposals that was generated by the first model, and then basically return a rank and find the most similar one that will lead to a successful visualization and helping the user accomplish their tasks. And then so what we ended up doing is training a model to basically predict contextual similarity. And I want to share with you some of the results. So here we took the model DistilBERT. We actually started with BERT, but it turns out that using DistilBERT speed up the training by twice and also only reduced the accuracy by only 12 points. So that was a very good trade-off. And we started with the accuracy of 33%, which is consistent with a model randomly guessing if the two sentences you gave it is similar, or if it's contradicting, or it's kind of neutral, not really sure, right? And in the end, we're actually able to achieve accuracy measured by F1 of 75%. So that's a pretty significant lift. So here are some really interesting examples that I pulled out I wanted to show you. The first sentence is, a friend drove to my house to visit with some candy. And the second sentence is, my home was visited by a friend who came with sweets, right? I'm pretty sure I made up this example because it's, not even grammatically correct. It's very complex. The words are very different. However, the model was, able to identify this actually meant the same thing, right? Even though I was on purpose trying to confuse it. And then giving you an example of contradiction, we're going to skip the neutral case because that's not very interesting. This next two sentences is, version 1, two dudes are observing something together. And the next one is the two guys are sitting with their eyes closed. Now, if you look at these two sentences, they have a very similar structure. A lot of the words mean the same thing. However, the actual meaning is, the polar opposite. And the model was also able to successfully identify that, right? So after all of this, the result is that we're able to use open source data using open source models that we kind of took and fine-tuned using free compute resources provided by Google Colab to cobble together a product that is now actually somewhat helpful and usable to users. So what that actually allowed us to do is to do reinforcement learning with human feedback, right? So it's able to basically make suggestions that a user is able to interact with and also click on. And we're able to collect that now proprietary data and use it to fine-tune a model. But notice how this entire process up until the final point was all done using open source resources, right? So even if you're working in enterprise, you have the funding, it's easy for you to, spin up a Vertex AI instance and train a bunch of models. It's so much fun, like not painful at all. You should still think about doing open source first. So if we are able to show you that open source is very powerful, it's very useful, then the question might be, where do you fit in and what is in it for you? And here I wanted to share kind of how I think about the open source world as a symbiotic ecosystem, right? So first, let's answer the question, who's who in the OSS zoo, the open source software zoo? So this is what I call, in my mind, the world graph of open source, right? In the center, you have an open source AI project, and you have different roles such as maintainer, these are the leaders of the project, contributors, these are the lifeblood of people working on open source software, and in the end, you have the users, because without users, your projects are kind of not that useful, and also you have funders, people who have access to resources and have a vested interest in de-risking or maybe, experimenting or giving back, right? More tangibly, this is how the different roles function and how they depend on each other in this ecosystem. Contributors are looking for growth, exploration, fun, and fulfillment. In fact, it's common that if you're a senior engineer, this is like one of your ways to have fun and also stay sane in a engineering job if you don't really have autonomy about what you're working on. Then you have leaders and maintainers. These are typically people who are kind of the technical, leaders of the project. They would love to have strong contributors. They would love to have access to funding and resources. However, a lot of their time is spent on, applying for grants, and therefore they're not able to move their projects ahead as much as possible, and they don't have as many contributors, right? And then in the end, you have users. Users benefit and want free, safe, trustworthy software, and they also want to have a voice. One of the benefits of working with open source software is that you get to have a say, whereas if you're working with a large enterprise, maybe that line of feedback and that influence isn't so direct, right? What they don't like is unresponsiveness from projects, not listening to feedback, not utilizing the data that's being provided, and also low quality projects. And finally, we have funders. So these folks actually have a lot of influence. They have resources. They have a lot of to give and to gain from the open source ecosystem. But they sometimes have a difficulty of deciding who they should work with, what kind of project they should support, and how to define return on investment, right? The kind of things they can, benefit from is de-risking, right? Open source as a environment or playground to experiment with cutting-edge experimental technologies. It is a source of free, trustworthy software, and also this is a little bit underutilized but very powerful. Open source is a great pipeline for talent, right? What they don't like is, deciding which projects to work with. They typically sometimes have difficulty with that, and also they don't like to, be subject to low quality code. So then the question becomes, what can we do to make the open source AI ecosystem function better? And I have some ideas to share. One of the key things we can all do is, improve the matching of funders, projects, and contributors by looking beyond vanity metrics. What do I mean by vanity metrics? It is kind of a list on the left of what people typically look for to indicate, is this a good project and is it healthy? Should I contribute? Should I join? Should I, provide resources? Versus what actually, in my experience, is a higher but a little bit harder to look for signal of quality and, key success factors, right? So maybe instead of looking for a beautiful GitHub landing page, look for the quality and freshness of user and contributor documentation, right? Instead of looking for diversity percentage in the leadership team, maybe look for churn of the diversity in the community and also the diversity of contributions, right? So these are just some of the examples and ideas. Finally, open source is very powerful. It is a great mechanism for improving alignment and helping people with skills and merits, but have some kind of traditional barrier to access bubble up in the ecosystem. But it is still quite far from being perfect, right? There's a lot of burnout in the community, and there's still a lot of bias and barriers to entry. For example, recently there was a project I'm working on, and me and this other contributor who's from Nepal was going to meet together for the first time ever and present at a conference. However, because I have a passport that doesn't require a visa and she does, the conference organizers simply were not able to get her visa documentations, to her on time. Therefore, she didn't get to go. So these are missed opportunities and things, small things that we can look at to continue to do better. So I want to kind of lead into a bit of a thought experiment and maybe discuss some open opportunities in open source, right? And open source AI. So for example, how do we use open source AI to improve the future of work and learning? We have this reskilling challenge. A lot of the old skills and jobs will be replaced. And yet there's so much potential opportunity for AI to collaborate with humans to massively improve productivity. What can we do there, right? There were jobs that are being kind of, removed. For example, a fast food chain recently kind of, took away the jobs of the drive-through order takers, but could we not have offered them a little bit of training so they can become kind of trainers for these AI agents, right? They know domain context. They are the people who are best at that job previously. Could they not basically take on a new role with a little bit of training to improve AI, right? That's entirely possible. How do we do that? Next question is, what would be a set of KPIs and best practices to track community health and project health, right? And also, if open source is such an effective way for corporations, enterprises to improve employee morale and benefit from new technology and get access to talent, what would be a very good template for an effective in-house open source program, right? And finally, can we use open source AI to change ethics standards in governance and corporate behavior? So with all of these in mind, I wanted to introduce you to a new project that I've been working on, and hopefully you're able to see this demo up here. So this project is called Bountiful Futures, and it is a way for us to expose machine learning model internals using a visual interface. Now, humans are visual animals, and we have a lot of good intuition, like visual intuition, right? So, for example, when given this data set, let's say we're doing some kind of anomaly detection, how many samples do we need? And what should be the confidence band, right? Without even much kind of machine learning experience, this is a way for someone to go and tangibly interact with the model and see how it behaves, right? And then, so if we wanted to use a real world use case, what we could do is, upload your own data set, right? It doesn't need to be something prescribed. This is a way for people to export their data without, actually having to write code. So, for example, I just uploaded a data set that has to do with Apple stock prices, and we're going to basically select that data set. I want you to observe that the table here has changed in value, giving this model a second here, and also it's able to I need to select the value in question here. And also it's able to essentially perform an update, right, and do a little bit of AutoML. Now, if you're a trader and you want to work with generative AI without being an AI expert and you want to be more productive, you can say, hey, I want you to generate a trading signal when the actual data points are out of the expected range, right? For example, the orange band. And therefore, if you're trading and you have a specific strategy, how sensitive should this model be, right? You can adjust the values and also record it down, right? So this is an example of a domain expert without having to know too much about machine learning or even technical details, communicate information, feedback to machine learning people about how the model should behave, right? But you could easily extend this to a example where this is just open to the public and general stakeholders, right? Say you have a censorship algorithm you're about to launch onto a platform, and you want to give communities feedback about how it should behave, how sensitive it should be, or even allow users to set individual limits for how they prefer the algorithm to behave for them, right? So you could say, hey, if the algorithm is too sensitive, then everything gets rejected. Therefore, there's no freedom of speech. Is this really how we make progress as a society? Or you can say, if the algorithm is not sensitive enough and very toxic, hurtful things ends up being seen on the platform, is that really what we want for this community, right? So now all these questions you can answer. You can get feedback from your stakeholders, and this is a way to essentially build trust in your algorithm, and also an opportunity to improve the safety, transparency, and the performance of your AI before you launch it into production, right? Now, the second part of this experiment is also fairly interesting, and we're able to get good results from it, and that is what happens if we provide a machine learning training data set that may contain some bias, or a machine learning training, a prediction model that may contain some biased results, right? Can we ask the general public or stakeholders who are interested, who are maybe not machine learning experts but have a vested interest in that use case? Can we ask them to provide feedback and spot where things are maybe going a little bit wrong? Can they bring up questions we should look into, right? And this is exactly what this is meant to do. Here we have a potentially biased data set that has to do with credit applications and credit scoring. And also we're able to see some of the fields that the model has deemed to be potentially sensitive. And people are able to essentially interact with this data set and slice and dice to be able to identify potential bias, right? So here is an example of understanding how does being in certain ethnicity categories and being the gender male affect your credit application, how many times you have to apply, and also your credit scores. So we are actually able to find interesting results after running this as experiment at a Mozilla trustworthy AI hackathon, right? For example, someone was able to say, hey, for your anomaly detection algorithm, I think the value of 17 and 1.08 would be the best values for sample size and also your sensitivity. And someone else was able to identify immigrants have a higher average number of applications despite having higher, average credit score. Is this bias, or is this supposed to be because maybe there's documentation problems? And finally, someone was able to say there's a possible imbalance in the number of males and females across the data set, right? And finally, the last feature I wanted to show you is that we recently brought on a new contributor, and she's not, as deep in the ML journey as, people already working on the project. And she was saying, "Hey, Maddie, it's actually really hard for me to, use this product because there were many things that I don't understand." So what we're actually able to do is build a tool to use generative AI to help people learn about AI. For example, you can select a term and make an API call and ask, Google's PaLM API to explain to you what exactly is a Gaussian process, right? So this is the explanation, and that's pretty cool. And maybe you're curious about, so how does this apply to anomaly detection? So we're also able to do that, right? Give me a minute here because PaLM is a larger model. So that's what I wanted to show for this particular demo. Let's go back to the slides. So I want to take a minute to thank the people who are core contributors on the team. This is Shashi, and I don't know if we can play the video to have Shashi introduce her in her own words.
Hi everyone, I'm Sasi from Nepal. I'm a machine learning engineer and I work in Open Knowledge Foundation on software development and machine learning. In 2021, I got chance to work with Maddie in open source project to develop a data privacy tool, and in last 3 years I've been contributing in that project and in other projects as well. And I also have a family of 2 children, is 16 and 12. And I have a lot of support from my family, even though like I have support, it's sometimes difficult for me to manage time as I have planned, because I'm playing different roles like at home and at job, and also due to social norms for women. And open source contribution has helped me a lot in my to improve my coding skills, my communication skills, and also helped me to network with like-minded people. And I can also now share my work easily because it's online. And above all, I really feel happy while I'm contributing, because I feel that I'm giving back to something back to the society. And I'd like to encourage females from many other countries to where there's less opportunity, to also come into the tech field and also join open source community and contribute in open source projects. And last week only we onboarded our new team member Daisy, and we are very happy to support anyone who wants to join open source community and needs help. So thank you.
Awesome. And here's our another contributor. So kind of joined the team and had to drop for other obligations, but we really got his back. He's also our resident security expert. And finally, Daisy. Daisy has a really interesting.
Hello, my name is Daisy.
Yeah, let's play that video.
Hello, my name is Daisy Mayorga, and I am the new open source contributor to this machine learning project for Bountiful Futures, and I'm really excited about this. It's a new opportunity for me as I was affected by layoffs and everything that comes with that. So I'm extremely grateful for this opportunity to get onto my machine learning journey and see more representation like myself in the space. So really excited about this, and thank you so much for everyone contributing to this project and having me on board.
Yep. And with all that said, thank you for being here with me and being part of this like open experiment. So we're working together with Bountiful Futures and Nita B, who's the organizer of Grace Hopper Conference, Mozilla Foundation, and OKFN. But more importantly, what about you, right? The future of AI is open source and bountiful. How will you be a part of it? If you are a company working on machine learning and you want to get feedback from diverse stakeholders, work with us and allow us to help you improve your models. If you're someone with resources and funding, we would love to work with you so we can push open source machine learning ahead. And also, if you're interested in contributing, definitely get in touch. And if you're just starting out AI, come and play around with these models and help us catch bias and help be a part of the creation of a AI future that you would want to be a part of. With all that said, thank you so much. This is the end of the presentation.
Maddie, thank you so much for that presentation. That was a lot of really, really insightful stuff, and I appreciate it a lot. I did have a quick question. We're seeing an increase in the number of open source models that are being made available. Probably the most popular one these days is the one that from Meta, the Llama 2 model. But we're also seeing a lot of the big companies kind of incorporating them and making them available through their cloud resources. Yet a lot of people seem to like the notion of having an open source model that they can run on their own machine, that's on their desktop. What are kind of the trade-offs between those two almost extreme approaches, running the open sources locally versus relying on a big cloud provider to do so?
So that's a really good question, and I think there's pros and cons to both ends, right? If you're not a very like ML savvy entrepreneur, for example, it is so advantageous to you that people like Hugging Face and Google Vertex made these models so just point and click, right? It's going to enable so much productivity and innovation at a scale that we've never seen before. So that's awesome. But at the same time, not every individual or researcher, especially if you're coming from an unusual background, have access to those resources. So then the question becomes, what are pros and cons of that? What can companies like, Google or Hugging Face do to maybe improve access? But also, maybe it is a feature, not a bug, right? For example, if you don't have access to, massive, compute resources and you need to do inference, maybe you will come up with some ingenious way of quantizing your models and actually improving performance for everybody else. And if, the ML research community is open enough, they can actually take what you are finding and then publish it as research and basically help everybody improve their efficiency, reduce costs, and actually benefit the environment, right? So hopefully there's benefits on both ends, and we just do our best.
Great. Thank you so much.
Awesome.
Okay. Can you hear me, Maddie?
Absolutely. How are you doing?
Wow. So I'm here live at Cloud Next. Cloud Next is just about to end. It was amazing. It was all about AI and AI tools. Maybe not enough open source, but a lot of open source stuff as well. Thank you, Maddie, for an amazing session. And also thank you for jumping on this almost at the last minute. Like, it was really awesome to just have you come and talk to us. And I really love the quote you wrapped it up with. The future of AI is open and bountiful. Thank you very much, Maddie. Looking forward to connecting with you very soon.
Absolutely. Thank you, Anyeti. Peace.
All right, everyone, it has been 3.5 hours of amazing content. And I don't want to keep you longer here anymore. It was a pleasure hosting you. Want to say thank you to all our speakers who contributed content, who created their presentations and delivered it to you. Special thanks to Peter, who opened the keynote and gave us such a very thought-provoking overview of the future of programming in the age of AI, or as things continue to change. For my teammates, Madusha, Carolina, who's not here right now, it was awesome putting together this IO Extended event. Earlier in the event, we showed you snapshots, reels, slideshows of many of the amazing events we've had throughout IO season, starting from Shoreline to all the IO Extended events, more than 60 events across the US and Canada. And now we had a great time in Miami for IO Connect, and also had our own North America Connect, where all our community organizers came together. But more importantly, we're very excited that as today marks the end of IO Extended season, in a month, we will be in DevFest season. DevFest season in North America is going to be awesome. Please check out goo.gle/DevFest. There are going to be events all across major cities in the US and Canada, and a few schools, colleges, and universities as well. Look for the nearest GDG close to you. Join, sign up, find out what's going on in the DevFest. If you're a contributor or a speaker, please go ahead and make a contribution to DevFest. It could be giving a talk, it could be helping with organization, or it could just be telling someone about DevFest. DevFest brings Google's technologies, Google's community to you in a more intimate and more personal way. Alan mentioned this during his talk and said, connect with a GDG. We strongly, truly believe there is power in community. And I always say to my colleagues, my friends, me being here in North America is a testament to the power of community. So get close to community, get ready for DevFest, look for a DevFest near you. If there isn't one, reach out to influencers, tech community leaders around you. and get a DevFest started. DevFest season 2023 in US and Canada and all across the world is poised to be awesome. From me, Anyedi, and my co-behind-the-scenes colleague, Madusha, and my co-organizers for today's events, Anna and Jim, who you saw at the beginning of this event. It's been a pleasure hosting you to IO Extended 2023 wrap-up from the Google Developers Groups and the North America's Communities team. Bye for now.